place. So prescriptive maintenance actually, this having a lot of uses of smart sensors, cloud computing, industrial Internet of Things, big data, to generate data incentive, condition-based prediction of asset health and performance. Basically, there are algorithms that access the continuous data stream and compare them against the equipment model formed from historical performance information. The software seek recognizable pattern, and if discrepancies from the established norm are identified, the emerging issues are analyzed, and that is good enough to give us an indication that what kind of maintenance schedule we can uh, present. So since, yeah, so this is something interesting topic, Chairman, that it probably, if I start talking, probably it will go long, but I will cut short. So I will give you a little bit how the AI ML, it is our responsibility to have the knowledge sharing on how the things work, because in the future, the steel plant are going to be the smart steel plant, and then that's where all this new technology will play out and come into the picture. So there are actually the artificial intelligence, which having the subcategory as machine learning and the deep learning. So, and all this works on the data. So the first stage of this artificial intelligence, where the data acquisition is done, and these data are something like we capture from different sensors, which are probably applied in the blast furnace, maybe the BOF, or maybe reheat furnace. So wherever the sensors are applied, we capture those data. And if I talk about the refractory maintenance perspective, this can be the initial refractory lining thickness. This could be the residual lining thickness, shell temperature, processing time, metallurgical data, maintenance, and the refractory quality, application method, and all those things. Now, the second step is the data cleaning. And data cleaning in the artificial intelligence and machine learning is a big task. So as per Forbes survey, it was told that most of the data scientists invest their 80% time in data cleaning, and that's how it is important. So the data capturing, data cleaning are the key in effectiveness of such machine. If we talk about the data cleaning in terms of maintenance perspective, of course, like image of refractory condition, like the previous session we were talking about the mapping of complete ladle and mapping of the EF, and how those data looks like on the visualization on the the camera, like different colors represent the different temperature. The next one is the feature engineering. Something is related to us, like we are having the domain knowledge, we are probably having the subject matter expert, where the metallurgist comes, where the steel maker or iron maker comes, and then they come together and they decide that what are the key feature which we probably would be requiring, what kind of iron we would be making, what kind of a steel we would be making. And then there are the AI comes into the picture, where you do the modeling, you do the the AI things, and then it will be process. I will take you with the next step. This is just a basic one. So this artificial neural network is actually inspired by the the human brain. We have in the brain, we have a biological neurons, and these neurons are actually working in such a way that it take an input and process it and pass it to the different next neuron, and that's how the process goes on. Let me compare with the biological neurons with the artificial neural network. So this is how it works. This is completely based on the data which we receive. So the data is the important. You can see here the dendrites, which is having in our the biological neurons, which is the input, the cell nucleon, which is the node where the decisions are taken based on the different weightage, and the axon, which is the output. The synapses is the interconnected. It connect with one neurons to the another neurons. Yeah, one second, sir. I mean 1 minute. So here we have the different kind of layers which works behind this system. We have a multi-layer perceptron. So when we put together all these neurons in very the pack maybe 3, 4, 5, and that's how this machine start becoming intelligence when over the time. So here I just put in the perspective of refractory maintenance, how the all this AI will work. So input data may be the shotcrete output, maintenance data, production parameter, laser measurement of lining, shotcreting lining, thickness, blast furnace. So where we do the feature engineering and then the data clearing and of course shotcreting map, that how what we are going to do the shotcrete by the repair, and then the AI comes in the picture, and then you start getting these reports that how the behavior rate is happening inside any furnace and where you can take a better decision. So in the conclusion, the use of smart intelligent technology are transforming traditional maintenance practice into a smart maintenance practice. AI, ML, and digital twins are enabling their paradigm shift, which address some of the key challenges such as unforeseen downtime for relining, suboptimal, and excess maintenance practices. The best part is that it makes the workplace much safer. We have heard a lot of the breakouts and all those things. Those breakouts probably will become nil when we have this kind of system very well developed. The new smart technology helps to create a refractory wear model, precisely identifying the key wear influencing parameter, do the refractory benchmarking, and automate the maintenance. So this is basically a smart system which will actually help us going forward. I'm not saying now, but definitely it will go in big way. So this is how Ultron is doing it. So Ultron, we have installed one robotic arms, which is actually eliminating the manual intervention at our plant at Sevilla. So we have how we are contributing into the AI ML. So we have all the product lines which are actually eliminating the manual handling of the refractory. So during refractory, there are a lot of manual handling which we are substituting by the automation. So these are the manual and robotic shotcrete, which can be done in blast furnace, torpedo-ladle car, or reheat furnace. Then we have Ultron pump, which is something, normally the vibro-casting is considered as the best method to do it, but there are a lot of variable involved, and that's where we have automated it. And that's give much better performance with the speed and safety. Of course, we have a high gun, that is the advanced version of the gunning. This is a brief how Ultron has evolved over the last 108 years. And
Prakash,
these are our this is last slide, sir. So this is our footprint across the globe. We have been operating, and we are coming into the India. We are rolling all this product and solution in the Indian market. Thank you so much, sir, for giving time.
Thank you, Mr.
Any
Prakash.
question?
If there is any question, then one question we can take up. Bit louder, and then you are quite closer, so you can listen. Any prospective customer in India?
Yeah, a lot of prospective customers. We have all the iron and steel plants, cement plants. They all are our prospective customers.
Do you have any EA in sale also currently?
Yeah, please come again.
With Steel Authority of India Limited, do you have any in steel also? You have customer sale?
So yeah, so right now we are introducing our product and solution in Indian market. We are building our manufacturing plant in Dhenkalan, which is 60 kilometers from Bhubaneswar. We are going with the Monolithic plant, and hopefully we would be start offering into the market from January 2023. So as of now in India, our presence is not there, but yes, we have our presence in Europe, we have our presence in America, we have our presence in Middle East, and we have our presence in US.
Okay, thank you, Mr. Prakash.
Yeah, thank you, sir. Thank you
for a nice presentation. Now, our second presenter is Mr. Somnath Sinamapatra. His paper will be Refractory Raw Materials, Problems and Prospects. Mr. Sinamapatra is from CGCRI, Kolkata. Area of interest is refractory raw materials, beneficiation, sintering. He's MTech in ceramic engineering from University of Calcutta. He has a 6 years experience in HR Johnson, Mumbai, and in 2007 he joined CGCRI. He has participated in 30 number of projects in refractory raw materials, synthetic aggregate, high alumina castable, containing refractories. And he has publications 21 numbers in journals and presented 20 conference papers, and he has 2 patents in his name. So I'll request Mr. Sinha Mahapatra to present his paper.
Thank you, sir. Good afternoon. Topic of my presentation is refractory raw materials, its problems and prospects. My primary focus will be CSIR activities on these refractory raw materials. We all know that bauxite and magnesite are the two most important refractory raw materials, and here its demand will increase with the increase in the steel capacity. Now, India is endowed with both the materials, but problem is that Indian resources, they are impure. So they are not generally suitable for high temperature applications, so they are used in restricted for refractory manufacturing. As a result, most of the refractory companies, they depends largely on the imported materials. And if you see the cost for import for this mullite, bauxite and magnesite, altogether it is coming some around 2,500 crores, which is not a small amount. So value addition of these Indian refractory raw materials is essential to achieve the self-reliance or to achieve the Atmanirbharata. So I'll first try focus on Indian bauxite. It is the primary raw materials for refractory. And if we see the production-wise, India's position is 5th in the world. First is Australia, then Guinea, and India is 5th in the. And the bauxite resource in India is around, it is huge, 3,896 million tons, out of which 656 million tons are reserves and 3,240 million tons are resource. The major reserves are basically East Coast, that is Odisha, Andhra Pradesh, and the refractory grade bauxites are mainly available in the Gujarat, Maharashtra, Madhya Pradesh, and Chhattisgarh. However, the problem is that out of the total production, only 4% of these either for refractory grade or chemical grade. The impurity present primarily is iron oxide, silica, titania, and lime. And broadly, we can categorize this bauxite, refractory grade bauxite in two groups. One is variety, one is where the iron and titania, along with this epitope and titania, CO is also present. And the presence of this impurity dictate the low melting phase formed in the bauxites. So if you can see the microstructure, in both the where one bauxite where it contains CO, another is contains CO containing low. In both the case, low melting phases are formed. In the first case where CO is not there, it is iron, aluminum, titanate. In second case where CO is also present, along with this, it also forms calcium containing low melting phases. As a result of this, what happened? Its high temperature property deteriorated, which is reflected by the low ROL value. And if you see the ROL value is very low, it's around 1450 like that. So these are not suitable for high temperature application. It must be evaluated. We must do something for the value addition of this Indian bauxites. So there are several approaches. One is beneficiation, which can be physical separation, which can be reduction resting, followed by magnetic separation, which can another is flotation separation, and last we can do the segregation by fusion technique. By this we can remove epitope and silica, and in the leaching process, which either can be bioleaching or can be acid leaching, we can remove iron, silica, as also we can leach out the lime. And by this process, this bauxite will be suitable for high temperature applications. And the third option, which is basically phase modification. If you can control the low melting phase formation by some by changing the phase assemblage or by tailoring the phase formation, then we can improve the properties. And CSIR, CGCRI work mainly in this area. If you see this solubility diagram at the bottom corner, this you can see epitope and TiO2, the two impurities present in bauxite. They have a good amount of solubility in mullite. Mullite is basically a solid solution, so it has good amounts of solubility for epitope and titania. So if we can convert this mullite before the formation of the low melting phase, we can restrict the low melting phase formation and thereby enhance the properties. So we have done some work with this. First one is bauxite where CO is there. First we straightway try to evaluate this, convert it to mullite. It is the low melting phase formation was restricted, but the mullite form are basically elongated in shape. Then we convert this, so we did a separate approach that we leach this CO with a minor acid, maybe organic acid, and we got almost equiax mullite, where the RUL values we could achieve 1630 degrees centigrade. At the same time, when we see the EDAX pattern of the mullite grains, it is clearly seen that epitope and TiO2 is incorporated in the mullite grains, and thereby it reduces the low melting phase formation. In the second category, where COE is low, the detrimental impurity is Fe2O3 and TiO2. The low melting phase is iron, aluminum, titanate, and that is seen from the EDX spectra of the low melting phases. And we did the phase modification with or without minor beneficiation, and we promote the mullite corundum composite formation by restricting the low melting phase formation, and that we have achieved by converting it to mullite. And you see the microstructure, it's almost low liquid phase is there, low melting phases are there, and RUL value is enhanced from 1450 degrees centigrade to 1600 degrees centigrade. These we have already upscale in a industrial level, and we could have been even at that industrial level. We also got very good result, which is very similar to lab scale product, and those are also similar to the imported bauxites. In the second, I will consider sillimanite bismuth. This is a very good source of aluminum silicate, and it's a pure form of aluminum silicate which is available in India. Impurity content is very low. If you see the chemical analysis of the two variety, one is Quilon and the Ostrom, you see the impurities are very low. It's less than 1.5. So the problem and reserve is around 131 million ton. This is basically a byproduct of iron ore minerals. We did value addition, converted to mullite. The problem with that is that as it is a very pure material, it's very difficult to sinter. So we judicially select the sintering additive to enhance the sintering or densification behavior. We did it both through briquetting route as well as nodulizer route, and the result you can see that we could achieve the specific gravity of 3.13, very close to mullite phase, pure mullite phase, and the BD is 3.04. With this aggregate, we prepare standard brick. We benchmark this brick with the standard available commercial level bricks, and the results we have achieved almost similar to identical to the commercial brick. So sillimanite bismuth, which is a pure material, can be evaluated because it cannot be used straight away as it is a very fine. We got in a very finer state. We need to be convert into aggregates, and we did it and we achieved that with good results. Third category is magnesite. It is the most important basic refractory raw materials, and Indian magnesite reserve is around 82 million tons. Resources on 312 million tons. The major magnesite resources are available in the states of Uttarakhand, Tamil Nadu, and Rajasthan. Though we have a good reserve, similar to bauxite also, as we have good reserve of natural magnesite, but again, it contains a lot of impurities and which restricts its applications. So now we see the Indian magnesite. We consider two predominant sources, that one is Salem and another is Almora. In Salem, you can see the CO and SiO2 are the major impurity. As such, CO is not detrimental because it will not form a low melting phase with magnesia. But when it is with silica, it will form low melting phases. In case of Almora, it contains Fe2O3 also along with CO and SiO2. So that Fe2O3 again can form dicalcium ferrite phase. And when CO and SiO2 is present, it can form depends on the ratio of lime to silica. It can either form monticelite, it can form marionite, and both the monticelite and marionite has very low melting temperature. They have a melting point of around below 1500 degrees centigrade. So it's quite obvious that we cannot use this magnesite for high temperature refractory aggregate preparation. There are several methodology we can adopt for the value addition of this magnesite. First one is basically removal of silica or Fe2O3. There are several processes. Okay, I'll take 2 minutes. One is we can rotation, physical separation, magnetic separation, and we can another third approach. You can convert the CO to high temperature compounds, and by which available CO can be reduced in the system for the low melting phase formation. In the first approach, we adjust the lime silica ratio and we have found that when the lime silica ratio is 2:1, it is beneficial in terms of thermomechanical properties, because if you see the XRD phase diagram, it forms dicalcium silicate, which is a very high melting temperature of around more than 800 degrees centigrade. Along with those, some maronite phase is also there, but formation of this C2S phase improve the property of Indian magnesite. In second approach, we have used some additive like ZrO2, titanium, and Y2O3 with the aim that these will react with CO and they will reduce the ability of CO in the system and thereby control the low melting phase formation. In case of zirconia, you can see zirconia, this CO is used by zirconia for its tetragonal phase stabilization, as well as it will form calcium zirconate, and thereby it reduces the monticelite phase formation. In other case, when we are using titania react with calcia and form calcium titanate, So that's why, and so the CaO is not available to form the low melting phases. And you can see the result for the MOR and the latent flexural strength. There's a lot of improvement is there. Though 1 and 3.8% addition is better, shows better property, 5% addition does not give the better property, and 3% is the optimum. When in another approach, we use reverse flotation process to separate the impurities. Mainly, our aim was to silica, and we used alkali amine, ether monoamine, pine oil as a frother, SHMP as a depressant. We adjust the different several parameters, and in this reverse flotation process, we could have. It is possible to remove the silica in this process. So it's a preliminary work. We need lot more work to do with this. And another approach is where we use a arc melting probe. We know that the impurity Fe2O3 and titania, they have a higher density. So if we can convert this Fe2O3 either to ferrosilicon or to metallic iron, those will be separated. Those will be separated due to through gravity separation. So we did a preliminary study within Almora magnesite, where the magnesia content 84.5%, and we have reached magnesia content of almost 92%. There is a long way to go to reach 97% or more, but this can be done through this arc melting process with proper selection of the parameters and this thing. So, in a remarks, I mentioned that India, though endowed with large reserve of this bauxite and magnesite, but they are low quality, restrict their high temperature applications. And as the nature of impurities and their content vary from one origin to another origin, so no single point problem is there, solution is there for this problem. So we need to tackle each and every material based on their impurity content. In CSA, we have done some work, which give good results, but again we need to go further. So as a result, we need a multi-pronged approach involving both beneficiation, arc melting, and phase modification in totality, so that we reach our solution. That's so the Indian magnesite and bauxite can be used for high temperature applications. Also, the co-development is the key for this challenge, to tackle the challenge. Thank you all.
Thank you, Mr. Sinamapatra. We can take one question. Yes, please.
That was a very nice presentation, sir. It's very heartening to know that Indian material can be converted to match the imported ones also. But when you do this, what will be the price? Whether we will be able to match those prices at which we are getting, and whether what is the feasibility of getting up to 97% and using that in our industrial application at the same price that is costing to steel now.
Okay. Fused magnesite, that step is already there. Fusion, already there is a charge. So what we'll do, we'll do some reducing agent or some additive by which you can achieve the separation. So if we compare the fused magnesia, I think it will be comparable. I cannot say exactly, but I hope it will be comparable. Because the same process is using for arc melting to prepare fused magnesia. Now, based on the charge, electricity, power cost, that will vary. Because we are not doing anything extra for this melting process. We use some additives. That's the key.
But imported ones, I think they are getting naturally higher MgO content.
But they are not doing the separation. For that, we are doing adding some additives and this. What I am thinking is the processing part. Processing cost may be the same. Only the additional cost will be the sintering, whatever additive we are using.
Yeah, I'm talking about the final products.
Look, cost to cost straight away you cannot compare maybe, but if you see the availability import, then your downtime and that is called, then the availability of this, like suppose bauxite, Guinea, some problem is there, we are not getting the bauxite. So those uncertainty is there. But if it is available in India, the transport and cost and this thing will be much less as compared to if we import it. Hopefully, we can achieve that.
It is in a very initial stage as far as magnesite is concerned. And further discussion we can have. Mr. Sinamapatra is here only. So thank you, Mr. Sinamapatra, for a nice presentation. Our next paper it will be presented by Mr. Sonko Chakra Chatterjee from Almatis. I'm not having his biodata here, but the topic of the paper is innovative solutions and trends of high alumina refractories for modern iron and steel applications. So, Mr. Chatterjee, you can start your presentation.
Thank you, Chairman, and good afternoon to all delegates. So this is my topic, and the content looks like the trend in end usage, trend in steel making and refractory consumption patterns, requirement in steel ladle, and then specifically focusing on alumina spinel type, and then some TCO aspects. If we start from the end market demand development wise, that means the pull strategy, what market needs, and accordingly innovation and planning and sustainable development planning will start. So 50 years before, the left side is the packaging steel demand and energy usage, etc. Right side, you have the strength of the automobile steel 50 years back and now 200 MPa to 1500 MPa. So this is happening at our end market. Accordingly, what is happening in the metallurgy and the metallurgical processes is that the impurity of the steels, automobile steels, and ULC grade steels, alloy steel grades, all these are coming up. To cope up with this demand, we need to change our process route, and that is given here. And accordingly, the processing time may be from 15 minutes to 1 hour now. So this is the effect of end use in our industry, demand of end use. Now, if you see the refractory consumption and cost in steel production, you see the highlighted one, the secondary steel, where the consumption is 35% of the whole integrated steel mill, and the cost impact is 42%. So that is considered now. Henceforth, I am focusing why on steel ladle and steel ladle refractories, that is given here. And we know what is happening here. That means it's a metallurgical vessel, like a metallurgical reactor. All additions and removal and bringing up to the special steel quality, lens and vacuum degassing, everything is done here. Okay, so that is towards the clean steel making technology happening. This is a combined picture of different sorts of secondary steel making processes you can see here. Now, if we see again, look back a little differently, steel production and global steel scenario, what was the situation just 1 year before? So China is there, and they are more than 50%, and still having optimistic growth planning for steel production. And there are a lot of other things happening within China, like closure of low efficiency steel plants and blue sky. That means sky should be clear, CO2 emissions, and cost optimization, all these things. Just 1 year after, the dynamics of whole global steel markets has changed due to international political scenario, and then affecting the energy and all these things. So there is a clear dip. So this is the global scenario, but we are in India. So what is happening here, that we are already second largest steel producer. Last 5 years, steel production is 100 million up, still having very good growth potential. When rest of the world is sinking, we are still in 5-6% positive always. Now, 2020, I was seeing that the Indian steel groups, they were in the top 20. If we see, 3 groups are from India there. And now, if we see in top 25, 3 were there. And now we see in top 23, these 3 are there. So that means Indian steel plants and steel groups are increasing their capacity. Over the last 2 years, India became net exporter of steels. That means a lot of you are exporting steel, especially automobile steel, to Middle East and Southeast Asia, some special grade steels to US also. So this development is occurring in the small cities, tier 2 cities, say smart city development, all these things, and it is 10% CAGR plus. And picture is not clear, though it is 6 months before picture when political situation was a little different political situation, but here you see India showing positive in 2023 and rest of the countries, Germany here showing positive, but now it will be just a minus before. Okay. Which direction we are going? Now this is a very old picture, but still very prevalent. This is the specific consumption of synthetic alumina in per ton of steel production. And we see the developed countries are in the range of 1.2 to 1.4. India, China were at 0.5 level 5 years back also. And now we see that China, from this picture, China has evolved to 0.6, India has evolved to 0.7. So this is really a good development going on in these developing countries towards incorporating synthetic aluminas for their final metallurgical demand to reach the performance, not only the performance, also the reliability factor, and the specific consumption of refractory is going towards the global standard levels. Still there are gaps, 1-2 kg, but we are working on it, right? Now this is a picture where the prerequisite and focuses in the steel making 1990s. 10 years after, we see that lining life can be compromised on reliability factor. Refractory cost can again be compromised if ladle capacity and steel quality needs to be improved, and little more focus on energy saving. What is now is this. So we see there is the green line where sustainability getting key attention. And as I told, lining life and refractory cost, you see the blue one before, and then we are ready to compromise on it if my reliability in the performance and end demand meeting, the steel quality demand is supporting, ladle capacity factor is taken care by these two compromise, and also the energy saving part. The ongoing demands of precast elements or slide plate, these functional refractories are very high. They need to be zero error, and reliability factor is outmost. So these are already proven material, but the new development in the direction of synthetic alumina based castables or bricks in ladle walls or bottom in case of both type of metallurgy, aluminum kiln, silicon kiln, it is coming up. High performance driven ASC brick, which is alumina silicon carbide carbon brick for torpedo ladle, AMC brick, alumac carbon brick for steel ladle, and different PCPF solution, not on the just the application. There are a lot of things in the material development also going on, which I shortly highlighted in my next slide, like ULCC and NCC based castable and then precast in RH snorkel, delta precast, and all other things. Now quickly in the focusing on the steel ladle lining, that what is the difference in Japan and North America, Europe, what is the focus development, but then we'll focus here that why and why not alumina spinel monolithic ladle lining in India, where the advantages, we know the automation and manpower saving, faster installation, long life, lower specific consumption, but the hurdle is that investment in the equipment. We do not want to throw the deformed ladle sometimes, training and experience in the shop floor, and the management commitment for this technological change. And these are the proven technologies available with a lot of refractory suppliers present in the material, and its lining is not only the one, the working type working principles also play a very important role. Here's a picture of ladle preheating. So it is as important as ladle casting and material designing. And supporting reported world control, I will not go in details. These are taken care by different previous speakers. But then also monolithic lining give you the relining facility, and the recycled material reuses, all this facility also. You can build up on the leftover thickness and the wastage will be minimum. So reuse part we can focus. So monolithic is the really advanced lining where if we see the global standard of where lowest specific cost of refractory is catered, these are the monolithic lining. And India, in absence of these things, we are doing with fired spinel brick. And these are taken care by the metallurgical demand and for the thin slab casting also. Now, I will touch upon some TCO approaches. Another 1 minute I will take. That the TCH approach is yet to come or just beginning. Here is the picture. If you see, the blue one is safety and this is working lining. By incorporating a better and reliable refractory lining, if we can reduce just 10 millimeter in the available working lining thickness in 200-ton steel ladle, we can cast 2.5-ton steel in single heat. So that makes the steel business more lucrative, right? And the solutions are obviously with reduced graphite content or carbon-free content linings, where we can really reduce down the graphite content, and at least for where really magnesia carbon is essential, we can focus on that, and rest of the things we can eliminate to synthetic alumina. If we really need to achieve the ULC steel demand, where carbon is in ppm just, so 1 to ppm will also make real change. This will also save energy, not only for reheating and also for temperature reduction and processing time, CO2 emission, and metallurgical demand achievement. And this is a picture to show that if the same operating parameters, same steel plant, a lining can save just 15-degree thermal wastage loss. This saves 50% of your total refractory cost. So as I told, the refractory manufacturers are available, refractory raw materials are available in India. So it is only our commitment and sustainable planning to think over that which direction we want to make our strategy. So to sum up, the secondary metallurgy, as I told, is the key focus in clean steel making. Production routes need to be stringent to meet up these demands. Flexibility in metallurgical equipment for meeting this desired quality is also important. High purity refractories are very essential to give the reliability, also cost consumption optimization. Energy and resource factor are very important to achieve all these goals. TCO approach is still in very nascent stage, and we need to develop it, and there will be a lot of saving, just not look at refractory cost or raw material cost, something like that. And modern alumina refractories based on synthetic alumina provide cost efficiency. So to remember this, that ArcelorMittal, what they told, that refractory related operation cost is almost equal to directly spent refractory cost. So we need to focus on the reliability of that. And as Rinus told, that refractory is a tool to produce steel. Thank you. For more details, you can contact me directly.
Thank you, Sonko. We may take one question, please, if anybody. Mic at the end. You need mic at the end. If there is none, thank you, Sonko,
Thank you.
for a nice presentation. Our Next presenter is Mr. H.L. Roy. He will be presenting on the paper Challenges and Opportunities for Refractory Industry. Mr. Roy is Managing Director, Zirconia Refractories Limited, Gujarat. His area of interest is business management. He did his MTech in ceramic engineering in 75 and BTech in 75 and MTech in 77. He's a gold medalist there from his college, working since 45 years in super refractories, and he has started his own company in 1996. So I'll request Mr. Rai to start your presentation, please. No issue, sir. You can always start from your place also. Yeah.
So I would like to be excused. Can you put the object?
I'll get it second.
उसको बड़ा करना है
इसको बंद कीजिए सेकंड वाला ऊपर वाला
नजदीक.
Sir, I will only request you to please stick to the time because we have already
No,
overshot the time. Yeah.
Whenever you say, I'll stop it. No
Okay.
problem. तब तक मैं बताऊं, मेरा लेक्चर हिंदी और इंग्लिश में मिक्स होगा. मैं आपको कुछ सिखाने नहीं आया हूं, मैं आपको जगाने की कोशिश करूंगा. मैं हार्डकोर टेक्नोक्रेट नहीं हूं कि मैं कुछ हाउ फ्रॉम राइट फर्स्ट पेज. I can't say. Shall I push it? Yeah, as you see the subject, challenges and opportunity for refractory industry, ये मेरा subject है. Before I go on this one, certainly आपको थोड़ी surprise होगी क्योंकि हमारी company और मैं popular नहीं हूँ आप सबके बीच में. Maybe 99% people may not be knowing who I am and what is this company. So before I go on this subject, basically मैं कुछ company के बारे में बताना चाहूँगा. मैं 1975 में बीटेक किया था, 77 में एमटेक. Then first 4 years I worked with the Carbonadium Universal for manufacturing super refractories. At that time the job was silicon carbide, bubble alumina, table alumina. जबकि उस समय पे पूरी रिफ्रैक्टरी इंडस्ट्री को ये सारे शब्द बहुत नए लग रहे थे. अब हर आदमी बहुत जानता है टेबल एलुमिना और सारी बातों को, बट एट दैट टाइम इट वाज ए वेरी न्यू थिंग. आफ्टर दैट जस्ट स्लाइड्स. This is my office. For example, the first product you see, crucibles. Till 1981, there was no crucible manufacturer in this country. The first plant came in 1981 with German collaboration. I joined them as a project manager. So by virtue of that, crucible के लिए I am the pioneer, भीष्म पितामह इस देश का. Still I am doing the major जो crucible की जो हम जिसको कह रहे हैं, crucible is not the platinum crucible and fused silica crucible जो आप यूज जानते हैं laboratory वाले में. हमारी क्रूसिबल साइज मिनिमम 5-10 किलो से लगा करके 4 टन कैपेसिटी की होती है. एंड द एप्लीकेशन इज कॉपर, ब्रास, एल्युमिनियम, गोल्ड, सिल्वर, जिंक. दिस इज द एप्लीकेशन एरिया. इसका 2 एग्जांपल मैं इसका यूजेज बहुत सारे एग्जांपल्स हैं बट 2 एग्जांपल मैं आपको दूंगा. जितनी भी व्हीकल्स हैं इस कंट्री में बनती हैं, सारे के सारे जो उनके ऑटो कंपोनेंट्स हैं, दे आर 100% विद एल्युमिनियम. And aluminum auto components are made with the high pressure die casting and low pressure die casting. And both these processes, they use crucible. We are the biggest supplier of crucible in this country. So एक application है कि किसी भी गाड़ी में, आपकी गाड़ी में भी हमारे कोई indirect contribution रहा होगा, whether it's a car, truck, vehicle, tractor, जो कुछ भी है उसमें होगा. सेकेंड थिंग, वही कार से रिलेटेड टायर, जिंक ऑक्साइड मैन्युफैक्चरिंग क्रूसिबल में होती है। जिंक को सुपर हीट करके वेपराइज करते हैं, फिर एयर इंजेक्ट करके दे मेक जिंक ऑक्साइड, एंड जिंक ऑक्साइड इज ए very important ingredient for tire industry. It gives polymerization of that product and gives lot of flexibility and strength to that one. So वो जो product है ऊपर वाले हमारे पास, वही हम वो stopper head आप जानते होंगे शायद, ये steel foundries के लिए we supply. Second and third product if you say, ये Indian Railway for manufacturing wheels. India was making earlier all with the wheels they were making with the hot forging process. 1978 में they got the technology from Griffins USA, जहाँ पे casting process से बनती हैं। बहुत बड़ा plant है बैंगलोर में, रेल व्हील फैक्ट्री कहते हैं उसको। But they were importing as part of the agreement, they were importing 100% all the item from USA. 91 में देश की जो foreign exchange reserve था बहुत कम हो गया था। They were compelled to go for the Indian substitute, and they had many places पे जाकर के exhibitions किया था. Luckily, I had the opportunity to visit in Bombay, और मैं luckily उसको develop कर पाया। तो second and third product almost exclusive supplier हैं, हमसे सीख करके हमारे लोग छोड़ करके कुछ एक दो और बना रहे हैं। So practically जिस भी ट्रेन में आप चलते हैं, चाहे पैसेंजर है, फास्ट ट्रेन है, गुड्स ट्रेन है, उसमें हमारी कहीं ना कहीं छाप होगी। सारी चीज़ें वो हो रहे हैं, हम करते हैं, स्पेशल प्रोडक्ट है वो। यस, फिफ्थ एंड सिक्स्थ प्रोडक्ट इज फॉर एसजी आयरन पाइप बनाने के लिए जिंदल, टाटा मेटालिक, ये हमारे कस्टमर हैं। दिस इज फॉर द कार्बन को ग्रेफिटाइज करने के लिए कन्वर्टर होती हैं, दे कॉल द ग्रिफिन्स कन्वर्ट। उसमें ये हो जाता है मैग्नीशियम ट्रीटमेंट करने के लिए, एंड द लाइनर फॉर पुटिंग टू द स्पिनिंग। Of course, ये प्रोडक्ट बनाते हैं। लास्ट 5 years वी आर इन कंटिन्यूअस फ्लो कंट्रोल वाल्व प्रोडक्ट बना रहे हैं, ये हमारी हैं। स्लाइड प्लेट से रिलेटेड सब प्रोडक्ट हम कर रहे हैं। दिस आर द प्लांट्स, जस्ट टू गिव अ ग्लिम्स ऑफ आवर plant and machinery. This isostatic press we bought from Belgium, and this is the biggest in India in terms of volume, because this is 1.2 meter. Normally people are having maybe maximum 600, 800 or maybe 1 meter. This is 1.2 meter press we have. These are second side में आप देखेंगे flow control products हैं। Last में देखेंगे the crucibles we manufactured in the same, जिसमें we can, this is the size where you can have aluminium of 1500 kg, that particular size you can have. These are our toolings and all. Yeah, now coming back to this subject जिसके लिए मैं challenges and opportunity बताई थी, उसी सब्जेक्ट पे एक्चुअली थोड़ी देर पहले एक प्रेस कॉन्फ्रेंस चल रही थी, तो मिस्टर उपाध्याय ने मुझे कहा था कि आप भी वहाँ रहिएगा, तो मैं वहाँ इसी से सॉरी मैं समय पे नहीं आ पाया था। तो वहाँ पे भी यही क्वेश्चन, क्योंकि पत्रकार ढेर सारे थे तो क्वेश्चन हो रहा था। अभी डॉक्टर शर्मा भी थे और प्रोफेसर झा, सॉरी, आप लोग भी वहीं थे। क्वेश्चन था कि भाई ये क्या प्रोग्राम हो रहा है, क्या चीज़ हो रही है, तो मिस्टर रथ एंड सारे सीनियर लोग समझा रहे थे। वहाँ भी यही क्वेश्चन था कि भाई बेसिकली स्टील का प्रोडक्शन बढ़ता जाएगा तो रिफ्रैक्टरी भी अकॉर्डिंगली बढ़ती जाएगी। स्टील क्यों बढ़ेगा, रिफ्रैक्टरी क्यों बढ़ी, ये सारी चीज़ वहाँ समझाने की कोशिश की जा रही थी। तो अब जो फिगर्स मैंने दिखाए हैं, दे आर अ हाइपोथेटिकल फिगर, डोंट लुक एट द एक्यूरेसी ऑफ द फिगर्स। जो मैं डायरेक्शन, जो मैं दिशा बताना चाहता हूँ उसको मैं कोशिश करूँगा समझाने का, कि जो गवर्नमेंट ऑफ इंडिया की आज की करंट पॉलिसी है, नेशनल स्टील पॉलिसी 2017, जिसमें 300 मिलियन टन्स का एक प्रोग्राम रखा गया है बाई 2030, एंड आई होप, आई गेस कि होपफुली हो भी जाएगा शायद, बिकॉज एवरीबडी लुक्स टू बी गोइंग इन दैट डायरेक्शन। Not only then, I read in the papers that there is a committee which is working out to, when India celebrates 100 years, centenary celebration करते हैं 2047 में, जब मोदी की ख्वाहिश है कि इंडिया शुड बी अ डेवलप्ड कंट्री, नॉट द डेवलपिंग कंट्री। अभी फ्यू इयर्स में वी आर टॉकिंग ऑफ $5 ट्रिलियन इकोनॉमी, उस समय तो आई डोंट नो व्हाट विल बी, मे बी आई डोंट नो 15 ट्रिलियन और समथिंग वेरी बिग फिगर। तो आज की तारीख में व्हेन वी आर, आई हर्ड दैट इट इज अराउंड 120-125 मिलियन टन शायद कैपेसिटी है। So if you take the figure of 125 million ton currently in the year 22-23 में, accordingly refractory business जो मुझे इरमा की फिगर से मिलती हैं कि इस अराउंड 10,000 crores all in all, एंड यदि जो रास्ता है 125 to 500 मिलियन टन्स वाला रास्ता, उसको मैंने कुछ सालों में जस्ट ब्रेकअप करने की कोशिश किया है, तो रिफ्रैक्टरी इंडस्ट्री बाय द टाइम वी आर हैविंग 100 ईयर सेलिब्रेशन इट कुड रीच टू 60,000 crores ऑफ बिजनेस। यदि ये जाना है, इसको मान लीजिए कि सचमुच ऐसा होता है, तो मैं एक अपॉर्चुनिटी के रूप में देख रहा हूँ। नीचे मैंने लिखा हुआ कि आई सी दिस ए ग्रेट अपॉर्चुनिटी फॉर द रिफ्रैक्टरी इंडस्ट्री। अब जो रिफ्रैक्टरी इंडस्ट्री, हर इंडस्ट्री चाहती है ग्रो करना, कि हमारे शायद हम अच्छी प्रोडक्ट बनाएं, ज़्यादा बनाएं, टर्नओवर हो, अच्छी प्रॉफिट करो, लोगों को ज़्यादा एम्प्लॉय करें, वी स्टार्ट कंट्रीब्यूटिंग समथिंग टू गवर्नमेंट ऑफ इंडिया। तो उस नज़रिए से मैं देख रहा हूँ कि दिस इज़ अ ग्रेट अपॉर्चुनिटी जो गवर्नमेंट की पॉलिसी है। स्टील इंडस्ट्री ग्रो करेंगे तो साथ साथ हम सब ग्रो करेंगे। यदि वहाँ जाना है तो किसी भी प्लांट को करने के लिए दीज आर 4 की थिंग्स, मैन, मशीन, मनी एंड मटेरियल। यदि उसको मैं अब स्लोली मैं अपॉर्चुनिटी से चैलेंजेस की तरफ मैं ले जाना चाहता हूँ कि मशीन एंड मनी, दीज 2 पार्ट्स। मशीन में आई एम नॉट वरीड बिकॉज इंडिया इज वेरी वेल डेवलप्ड और मशीन बनाने वाले बहुत सारे लोग हैं। मशीन डिजाइन करवाई जा सकती है टेलर मेड, एंड वर्स्ट कम वर्स्ट यू कैन इंपोर्ट वंस इन अ वे। That is not a big burden because machine you don't buy every day. So I'm not worried about the machine. In fact, I'm not worried about money also because there are big resources in this country. Bankers are the big pocket, बड़े industries यहाँ बैठे हुए हैं, and money also probably with from the share market. So machine and money, I'm not too much bothered. I'm sure it can be organized. Now coming to the challenge in machine and money, I don't see this as a challenge. If I take the men particularly, I have big problem in front of me for everybody. I'm just giving my example. First is say my turnover last year was 100 crores. We are growing this year at the rate of 27%. So far in last 6 months, our growth is around 27%. If the same thing is true, we should be somewhere 125, 140 crore. We should be there. We have around 450 people working with me. Out of that, 75 people is skilled. Skilled doesn't mean engineers only. I consider the fitter, operator, kiln operator, purchase guy, all the skilled who has got some skill. So I'm having 75 people in my company. If the same ratio goes, by the time we go to 40,000, 60,000, I'm not considered at all. 40,000, we need 30,000 people. High quality products, if you consider, for example, flow control products. What is happening? Skilled manpower, top technocrats are very few, very little. What is happening? Change of chairs from Vesuvius to Tata, Tata to OCL, OCL to Zirka, Zirka to this. This is happening. And it's not a very good sign. I'm worried. Maybe somebody will get benefited for some time, but in long run, can we sustain this industry at this level? So for me, in fact, here I have thought of that out of 30,000, you consider the requirement is 15,000. Now the morning, Mr. Jha, Professor Jha was having the same question. For having this 15,000, how will you do it? Where from? So just I'm thinking that could be to talk to all kinds of educational institutions with government guidance participation so that enough infrastructure is in place to educate future employees as per future demands. Unfortunately, most of engineering colleges syllabus, if you go, they are few decades old. None of them will know anything about the isostatic press. None of them will know anything about new binding system. None of them will know anything about the new furnacing system, new combustion system, new hydraulics. So basically my statement is, I think maybe the steel industry, the refractory manufacturer should sit together. There are brilliant brains here, sit together and think in that direction what should be done. So one part is the infrastructure. Second, I'm saying is to talk to government educational institutions to redesign syllabus. for various courses to take care of refractory industry changing needs. There has to be two-way regular communication between educational institutions and our industry to be agile, to come up to the expectation, because the expectations are very high. Without quality manpower, you cannot make 300 million tons and 400 million tons. From morning, I'm listening, the specific refractory consumption quality requirements are going, how that will come? The same people who have been working for 40 years, can they do that? I'm sure probably no. There has to be new energy, new thought, new idea, and that will come with the new generations. Having recruited, second part, having recruited, having the different colleges and all. Third part, skill development, I'm saying this is after you have employed. You are having a person, the person has worked already for a couple of years. Now, there has to be some program for skill development of that person. He should get back to some institution, get the training and come back. I consider this as a very big challenge. And for this, one individual, one company cannot do it. I'm just worried. Industry association, top business groups are expected to take lead in this direction. So this is for me the big problem. Now, still bigger problem, the raw material. Right from morning I have listening, but I'm saying my experiences. For example, natural graphite, silicon carbide, these are my materials I import. Okay, sorry, I'll get back. I'm just closing this. Natural graphite, silicon carbide, silicon metal, ferrosilicon, aluminum powder, brown fused alumina, white fused alumina, borax, anhydrous borax, zircon sand, monoclinic zirconia, stabilized zirconia, fused malite, dead bond magnesite, fused magnesia, fused mirmol, all these materials, 100% practically imported. Either we import or we buy from somebody who is importing. Now the question is, I'll give one example. Of morning, somebody was saying Russia-Ukraine war. We import 100 tons of silicon carbide from Russia. Last 7 years, I am importing. 8 containers, I'm not able to pay to them because of US sanction. Because the container, earlier directly it was coming, they diverted through Iran, Dubai, and India. The moment there is a Iranian port is there, we want to pay, we are struggling, we are approaching government of India, we are approaching RBI. My bank is saying, no, I will not pay. The problem is shipping cost. The problem is payment. We are trying to say, hey, this is not our fault. This company we have been buying for at least 7 years. And what to do? All these materials, my worry is, if you depend on imports, the prices are not in your control. Dollar has gone 80 rupees. Shipping cost earlier, which was $400, we pay $8,000. Some products, silicon metal, it was 170 rupees a kg. It went to 760 rupees a kg. Now it has come down to around 250 to 60 rupees. Gas, Sabarmati gas there in Gujarat. It is Gujarat government and Bharat Petroleum together. It was 30 rupees per cubic meter. Now we pay 76 rupees per cubic meter. If you depend on this, and why it is again because of Russia-Ukraine crisis. Because Russia has stopped giving gas to Europe, and Europe is coming in the Middle East and area where from our supplier was giving. Now they have jacked up the prices. So here, now the thinking, you see, just by having beneficiaries of magnesite, can you solve, for example, item number 29. We use furfuryl alcohol. Many of you may not be knowing this material. We import from Thailand. My main binder, Carborous P, we import from Germany. Many items, chromite sand, we import from South Africa. Boron carbide, very little quantity is here. So basically my question is, how will you solve this problem? My suggestion, if you can put up 500 million tons of steel plant, thousands of crores of refractory, can't we think of manufacturing these items in India? For example, silicon carbide are made here because I have been buying silicon carbide from 77. Granular was doing wonderful thing. But problem is because energy cost is 80-85% for silicon carbide manufacturing, and energy cost is very high here. So basically, it's not the technology of silicon carbide is not available. Technology is available, but basically the association, the users should talk with the government of India, think for maybe give a special consideration for the energy so that can be. brown fused alumina, white fused alumina, tabular alumina. Can't we make it? It is possible. It was
Sir,
possible.
we have to be with the time because one more presenter is there.
I'm sorry.
And,
So basically,
and
this is.
after that, one more session is also there. So we'll be
So
delayed.
with this, I'm sorry because since I'm running out of time. So in case you have got some question,
Uh, if any question, we can take. Otherwise, we can quickly move to the next presentation. I'm sorry, sir, we could not give you enough time because
I
it
have
was-
one question, please.
Yeah.
One question.
Yes, sir.
First of all, I would like to congratulate Rai Saab, and I request the organizers that such kind of talk should be given certain time, because I tell you why. These are very challenging and burning topics. We have come here for knowing all these things, and unless otherwise you give certain importance to these areas, we cannot dream of becoming an Atmanirbhar Bharat. This I am sure. Anyhow, I must congratulate Rai Saab for giving the insight. My only one question is that Rai Saab, CGCRI is struggling very hard to make the crucible, make the refractory crucibles for melting that RSW glass, radiation shielding glass window.
somebody only day first day I got the inquiry. I have in my, we have a distributor for slide gate refractories in Mandi Govindgarh. He buys every month around 60 lakhs worth of material from me. So from somebody must have given him this photograph of Firozabad big pot,
Yes.
and he has forwarded to me. And I would like to make that one with isostatic process.
Right.
Because in my press is the biggest.
Yes,
and I
yes,
can
you
do
have
it.
the biggest press.
So I told him that you call my branch from Delhi. They will go take photographs and talk and see the possibility. We can one more thing I would like to request. If you give me time, you see, we buy the product with a specification. We focus a lot on the specification. I'll not name a company. The trial was conducted only last week. They buy product from USA. It is 2 meters long. They call tube, and it is mullite. It has the life of 2 heats. They approached us. Mullite we don't deal. We use mullite as a raw material, but we don't manufacture that one. But if you tell me, if you allow me to give even wood, give me the freedom. Don't test the material. If you want to test physical properties, I will match the physical, but not the chemistry. There the porosity was 18-20%. My porosity is 12 to 13%. How will I make the 20%? I have to dilute my product. And I'm telling you, we gave 2 heats. Other imported product was getting bent after 2 heats. My product was still okay. Now they are thinking, because it's a government of India, one project. Now how to go about that? We have done it.
These things, sir, these things happen. You have to look at the things from going the other side of the table also.
But
If there is a failure, the loss is so much that you can ask Mr. Rama is
No,
sitting
I'm
there.
just-
They
it's
are
just
steel
my
man. They
thought.
know that what is the loss we make because of that. So, sir, these things are there, and this will continue. We need to solve together all these issues. So, I'm sorry, sir, because we are getting really short of time.
Okay,
We have
okay.
got one more
Thank
presentation.
you. Thank you.
So our next presenter is Mr. Prashant Vaidya. He will be presenting a paper on adoption of corundum refractory lining technology in lime dolomite plant and major capital repair technique through top-down approach in Sail ISCO plant. Mr. Vaidya is a ceramic technologist from Government College of Ceramic 2011 batch and MTech from currently he is working with ISP. I will not go into the details. Mr. Vaidya, you can start your presentation. You have 10 minutes time. Please be in time.
Thank you, sir. Thank you, Chairman, sir, and respected delegates on that. Today, I'd like to present the adaptation of corundum refractory in lining and new lining capital repair technique, which we recently adopted in our ISCO steel plant, which basically reduce our downtime and also help to improve our quality of lime also. As a steel manufacturer, we all know that lime is an inseparable part because without a good quality of lime, we can't produce clean steel or a very good steel. Because without lime, we can produce a good slag. So before I jump into my presentation, a little bit walkthrough of our LDCP plant. In ISCO, we have four basically dual shaft clean. 3 is for lime clean, having capacity of 330 ton per day, and 1 is dolomite clean, which is having capacity of 200 ton per day. And this is the basic parameters of our kiln, and temperature we maintained around 950 to 1100 degrees centigrade for calcination. And the combustion system we use is Landsfire, and gas is basically mixed gas we are using for that purpose. And this is a basic flow chart of lime dolo calcination, where we fed the input material as limestone, coke oven gas, and blast furnace gas. Approximately calorific value after mixing is around 2600 kilocalorie per Newton cube. And as a final product after cooling, we get calcium lime and dolomite. And this is our basically outline of our dual shaft clean, where double shaft is there. One, when we fed from the one side, the combustion air and fuel, the calcination occurs in the shaft, and the flue gas passes through the crossover channel, which we can see here, and reheat the other shaft. So it is a gas recovery, heat recovery system. And by this, we saves energy, which is a burning topic now. And the refractory lining we are using, basically for the calcination zone, we are using magnesite refractory, and for the non-calcination zone, we are using aluminum refractory. And few mortars, aluminum-based mortars and basic mortars are there. Now the main key problems we are facing that due to the inconsistency of gas and due to the combustion system choking, we usually refractory gets multiple times of thermal shock, and due to that, our arch refractory, which we are, and due to this red spot is observed, and also this is also invites high maintenance cost and also breakdown time, and it's also adds on the refractory consumption for kg per TCS, and as an output we also get the poor quality of lime and dolomite. So initially what I mentioned, that magnesite we use as a arch material. Right now we switch to the corundum. Corundum is nothing but a alpha alumina, and having the thermal expansion, it should be plus 0.5% at 1400 degrees centigrade, and has better chemical stability. But here I marked it a red, that cost effectiveness is not there, because corundum is much costlier. Much costlier is compared based on our ISCO data, where magnesite we one set of arch cost around 32 lakhs, whereas the corundum cost us almost around 45 lakhs. So why we are using it? Actually, the lifespan, when our ISCO, the harsh condition is there in LDCP due to the gas problem, combustion system problem. So only within a year or maybe 1.5 years, magnesite arch got damaged. So we replaced it with corundum and started with one clean, and almost 2.5 to 3 years almost passed, and nothing we have to repair, so comparatively nothing. And now one more clean we have added, the corundum arch, and here we also passed. So the life we are getting, actually that compensating our cost. And as we know that corundum is the hexagonal closed pack structure, so having minimal microstructural defects or flaw. So, and it also provides the better life and ensure the ensure the spalling resistance, better spalling resistance compared to magnesite, and also very easy to use or handling because it is less hygroscopic. In fact, not hygroscopic, being not a hygroscopic material, it is easy to handling and storing, and lining can be done. Where magnesite, it needs to be taken care. And one more thing I like to highlight, that capital repair technique we have also changed. Usually most of the places during the capital repair lime clean, we emptied the burden completely and dismantle all the bricks, start lining from the fresh. So in that process, actually time is a factor. Almost 2 months it takes to a full repair of the lime clean. And also it is also wastage of refractory, because during the dismantling we lose out almost 60 to 70% of insulation material or safety lining, which is already intact. We can reuse, but we are unable to reuse. So in this process, in top down process, we actually do not empty the burden at a go. Just gradually we step by step and empty the burden and start lining from the top. So from the top, we start lining, maybe 15 to 16 layer, we down the burden and keep on lining and keep using the old bricks. And when necessary, we replace with the new bricks. And in this process, we have to ensure also safety. So we usually make the tie-rod welds. As the picture makes of these rods, actually, these are welded in several layers by using retainer plates. So these are also ensuring safety, so that when we go keep on lining to the downwards, the bricks do not fall down. So this also ensures safety, and also it cost effective as we are using the bricks. And also there is an add-on advantage of time, where earlier it was taking around 2 months or maybe 50 to 55 days. Now it's come down to around 20 to 25 days. We can complete the line. So basically, the key takeaway from this, that the corundum actually being not cost effective, it's not like that we can't use it in our steel industry or LDCB industry. By judicial use can also give us benefits. So we are taking corundum as a very promising material for the LDCB. And also the lining techniques we have adapted, maybe few other steel family member can adapt this technique so that they can reduce the downtime drastically and some reliable output from the kiln. And also without compromising we are reducing time and without compromising any safety. So this is all from my side. Thank you.
Thank you, Prashant. Saving some of we can take 1 or 2 questions. If there is, okay.
Hello. This your kiln has been designed by Simprogity, and the same designer is for RSP CP2. They are also facing the problem, so you should suggest them also, RSP people.
Okay.
Is there any delegate from RSP? Okay.
Give him the mic, please.
Sir, myself. We are facing, sir. So we will send somebody, 1 or 2 people from RSP to ISCO and try to learn. Thank you.
Okay. Thank you. Thank you, Prashant.
Thank you.
So with this, we end this session. We had 5 very good presentations in this session, though we have overshot by 10-12 minutes, but that's fine. Finally, the seminar is conferences for discussion, and we have to go with this. We had initially a presentation by Mr. Prakash about the. I'll quickly sum up because we all have heard the presentation, and those presentation were quite clear and very. I mean to say that I did not explain anything about the presentation, but the presentation was of Mr. Prakash was very good, and the about in refractory industry we are thinking of artificial intelligence and data science, and future is that only for better management, for cost effective way of handling the things or maintenance. So that was a very nice presentation by Mr. Prakash. The second presentation was on a very burning issue by Mr. Sinama Patra. We keep on increasing our production, but where from the raw materials will come, and see, we really need this type of work from our CSIR labs for our raw material security, because the future in India, refractory, the major hurdle will be raw material. What we heard from Mr. Rai also, he had been in this business for so long, but still for so long he had been importing so many refractory list. So CSIR labs need to come up with some practical solutions, implementable solutions. There are certain research definitely, but outcome should be that's a request to Mr. Sinama Patra. Mr. Shanko, a very good president, alumina and alumina spinel. Now gradually in India also, earlier we were not using, as far as my knowledge goes, our spinel castable didn't succeed much in India, but about the spinel bricks, gradually it is picking up, even in sale plants also. I was just talking to Mr. SMS2 CGM, and from October they are also going for the alumina spinel lining in SMS2 converter, SMS2 ladle. And as we go for low carbon steel, we have to think of anything carbon free refractory. That was a nice presentation, Mr. Sanko. We have a very provocative, very thought-provoking presentation by Mr. Rai. And the problem, what he was stating or discussing, those are the very genuine problem with our refractory industry, with the customers, about the raw materials. And you had been in this business, sir, for very long. You might have seen some issues have been solved. ठीक है, हम भारतवर्ष में थोड़ा स्लो चलते हैं, लेकिन आशा करते हैं कि फ्यूचर
बड़े पॉकेट वाले बिजनेसमैन हैं, they will think on this one and they will try to do something.
लोग सोच रहे हैं सर, people are thinking, ऐसा नहीं है कि नहीं सोच रहे हैं. हाँ ठीक है, मैं वही कहा कि आउटपुट हमें धीरे धीरे दिखता है, and we are hopeful, we should be optimistic. और
एक एग्जांपल मैं कहना चाहूँगा, नेचुरल ग्रेफाइट उड़ीसा में संबलपुर के आसपास में आज से 40 साल पहले बहुत मिलती थी, आज भी है. तमिलनाडु मिनरल्स करके कंपनी है, उनके ग्रेफाइट के बहुत अच्छे भी है. Today we import from Brazil and Madagascar.
I am also a sir customer. I am also a customer of graphite. I had been taking Tamil Nadu graphite earlier. Now we are not getting it. So
Madagascar is prone for natural disasters. कई बार हमारा पड़ा हुआ है, दो महीने तक डिस्पैच नहीं हो पाता है. तो we face abundant number of समस्या इतनी है कि कह नहीं सकते हम. हमारे जो दर्द है गजब है.
And the last presentation was Mr. Prashant Vaidya of ISP, and they have done a very good work and very nicely presented about the changing from basic to corundum refractories, and how they have managed the cost in a profitable way. After that was a very nice presentation by Mr. Vaidya. So I thank all the presenters. Now it's to Sunita, please.
Thank you, sir. By the discussion that we have just now witnessed, we can understand when technologies, manufacturers and users sit together across table, or they face each other. This is the kind of discussion that we often witness, and it's a healthy one. We must continue with this, like as I was saying, and we can join together to bring activities of this sort, and come forward with solutions of that, so that each one of us benefit from it. We can have a win-win situation from the manufacturer side, from the accommodation side, and from the industrialist, all coming together. And thank you, Chairman Sir, Shri R.K. Singh Sir, CJMSRU, for doing your job so well, summing up. And no issue, if the discussions are good ones, we can spare 10 minutes, 20 minutes extra. The House must bear with it. I hope the sessions are being interesting for the House. And co-chairman, thank you again, sir, Surendra Prasad sir, for being associated with the chairman and hosting the session so well. Proceeding forward, I'd request the session chairman to please hand over the certificates, and the co-chairman to present a memento to all the presenters. So we'll start with Mr. Prakash Bharti. It's from Alfran NRL. From CGCRI Kolkata. We have the third speaker, Mr. Shankha Chatterjee from Almatis. The next one is H.L. Raisa from Zirca Refractories. And last but not the least, Mr. Prashant Steel Plant. Congratulations to all the speakers for making a wonderful presentation. And I'll request now CGM SMS2 and CCS, Shri Amar Gupta sir, to please give a memento to the chairman and the co-chairman. So please, I request you to come up on the dais and hand over the mementos to the chairman and the session co-chairman. A big congratulations to both the chairman and the session chairman for hosting the first technical session so well. And a big round of applause for the whole session team for having conducted it so well. We'll take a short 10 minutes break and we'll assemble again for the second session of the day. A quick short tea break and we'll assemble for the second session. The tea is just available outside the hall at the foyer. We'll have a short break and quickly assemble back in the hall for the second session. We are already running short of time. We do not want to curtail your evening program. So we'll like to finish it on time so that we are already all weird out of the morning session. I request all the participants to be back quickly after the tea break, which is just available outside the hall at the foyer, and assemble back for the second session. Mr. Suchit Kumar Mahanta, if you are in the hall, and can you please come on the stage? Can we request the audience at the foyer to please assemble in the hall quickly so that we can start a session? We are almost ready, and we'd request the participants in the foyer, quickly finish your tea and please come back to the hall so that we can start a session. We are running quite late. So I'd first request the speakers of the session 2A on refractory for steel making, Mr. Suchit Kumar Mahanta, Mr. Kaushik Das Gupta, Mr. Abhishek Mitra, Mr. R. Pandey, and Mr. Deepak Mane. Please come up on the stage and take your seats. Mr. Suchit Kumar Mahanta, Mr. Kaushik Das Gupta, Abhishek Mitra, R. Pandey, Deepak Mane, and Ms. Pallavi Singh. Mrs. Pallavi Singh. And we have one paper that will go online and it will be presented by Mr. Ashish Kumar Sarkar, followed by a combined presentation by JSW Dolvi. You can sit anywhere. Yeah, Pallavi, sit at the bottom. Pardon, sir. So it will be 8 if we add JSW Dolby. Yeah, it will be 8 papers. So just give a common discussion at the end. That will be convenient. So we'll begin with the second session of today's conference that's on refractory for steel making. We have our speakers on the dais, and I'd request our session chairman, Mr. M.R. Gupta, sir, CGM SMS2 and CCS, and co-chairman, Shri Sushant Sarkar, sir, GM in charge SRU, to please come up on the dais and take your seats and take forward the session, sir. A huge round of applause for our session chairman and our speakers on the dais. So please welcome our guests and our speakers. Let us all be motivated, although it's the last session of today. We are all tired, but we can just brush up ourselves. We have a short tea, and we can make ourselves alive so that we can hear to what the speakers have to say. Mr. Sushant Sarkar, GM in charge SRU, has been long associated with RDCS at Ranchi, and now he is working at SRU as GM in charge. And I request, sir, to please take over the charge and proceed with the proceedings of the second session and give a short introduction of our session chairman.
Before I hand over the mic to Mr. M.R. Gupta, I will read out something about Mr. Gupta. Mr. Monish Raj Gupta is a consistent first honor student and a mechanical engineer graduated from RDC Bhopal in 1991. Never contented at his search for knowledge, he also took his PG DIM degree in 2013. He is very studious all along. He joined SAIL as MT Tech in 1991 and posted at SMS Durgapur Steel Plant. He has a vast experience of working in almost all sections of SMS like converter, caster, including lime plant in various capacities. During this period, he was associated with the conceptualization, erection, and successful commissioning of many projects. He was transferred to BSL, Bokaro as CGM SMS1 in 2020 and entrusted with responsibility of ladle furnace and slab caster, which was achieved successfully in 2022. And BSL became 100% slab producer through caster route. In December, he was assigned with new responsibility of heading SMS2 and CCS of BSL. And now he has taken up many new initiatives for debottlenecking of SMS2 CCS for capacity building. Distinction was never separable from his studies as he constantly received numerous scholarships, merit, awards, and gold and silver medals. As recognition of his achievements and contributions at SAIL DSP, he was awarded NMD by IIM Durgapur. While doing several creative and innovative jobs, He also patented one of the most effective patent that is designed for VAD HRS device. Now I will hand over the mic to our session chairman, Mr. M.R. Gupta, please.
Thank you, Sarkar Sahab. Thank you for the nice introduction and the honor. Uh, thank you, the organizers, for giving me this honor to chair this session. We are already late from the first session. So in this session, basically the topic is refractory for steel making. The topic is very close to my heart because I have been a steelman right from the date of joining in my sale. So last 31 years I am in SMS only, and the SMS people knows what are the challenges and what are the requirements they are looking from this refractory industry and refractory manufacturers. Particularly the message from our DI Saab, DIC Bokaro, what he said in the morning is the productivity, cost and quality part. So the cost of the refractory in this steel making plays a major role. So how we can reduce the cost, and what I see from the 8 presentations which are to be taken up in this session, all the topics are focusing primarily on the cost and quality. So I hope we get a very positive outcome of the session. There are 8 speakers from TRL, SAIL SRU, RHI, Dalmia, JSW. There will be a combined session from Odisha and Dolby, SRU, RDCS again, and Mathan Ceramics. So as I told you, the time is constant here. So please don't mind. We will be having a very short session, 10 minutes, and after 8 minutes, I will just prompt you to close the session as quickly as possible. Thank you. So start with TRL Kurosaki Refractory Limited. Speakers are Mr. Gaurav Pandey, Suchit Kumar Mahanta, and the whole team. Mr. Suchit Kumar Mahanta is a BTech in Mechanical Engineering from TRL Kurosaki. Experience in the area of flow control, refractory mechanism, Tundish refractory and mechanisms, refractory applications. For last 13 years, he has been associated with many projects, Pokayoke and TRLK slide gate system for ensuring slide gate closing during tapping operations, development in backsplash production covers for safe operation in TRLK slide gates, mechanization to improve the productivity of by 28% of central maintenance shop at Dalmia Bharat Refractory Limited. He has 2 publications and patent also that is in applied. So I welcome Mr. Suchit Mahanta. Please start your presentation. Thank you.
Thank you, sir. Good afternoon to one and all present here. This is Suchit from TRL Kurosaki Refractories Limited. The dignitaries and Dr. Dias, my friends, it gives me an immense pleasure to present our topic, that is the cost-effective refractory handling manipulator for safe and better agronomics. I will take you through the background, the concept of the manipulator application for slide gate nozzle fixing, and finally the conclusion. In the steel making shop, by the basic oxygen furnace, it is converted into liquid steel, and then further purification is done in the secondary furnaces like RH and LF. And finally, the liquid steel is shaped into billet, blooms, or slab in the continuous casting process at the cast house. In total process, variety items of refractories are used, and that depends upon the process, desired performance, and application. We TRL Kurosaki cater all the requirements to give refractory solutions. In the continuous casting process, ladle is the common entity that moves from one station to another station. And ladle is the vessel which is the refractory lining, in which refractory lining is done, and it contains 2 tundis. So as you can see in the figure, here there are different stations in the steel making shop in which ladle is continuously transferred from one station to another station. Slide gate refractory changing, porous plug changing, ladle bricks observation are being done, and ladle is sent for the next cycle. During changing of the slide gate refractories, mostly we change the upper nozzle, the slide plates, lower nozzle, and here the most top job is the changing of the upper nozzle, because upper nozzle in changing of upper involves the carrying of heavy weight and the lead time that is 30 to 40 minutes. At the same time, many safety hazards are involved. So we have taken this as a challenge, and our aim to make this process simpler, safer, and user-friendly. So let us understand what is the current practice and problem associated with this. So for fixing up the upper nozzle, first we have to lift the upper nozzle through a jig, and in this jig, it is there is a chance of fall of the upper nozzle always, because there is no positive locking with the jig. And next we have to apply motor on this. For this we have to rotate the upper nozzle manually, and there is also a chance of fall during application of the motor. Of the motor and fix in the well block. For this we have to proper positioning of the upper nozzle to be done. So in this process there is always involved the operator fatigue, which may lead to the back strain of the operator, and the safety hazards like burn injury may occur. So in this process it is quite difficult and time taking process that we are earlier it was there in the practice. Solution by which we can overcome this problem. So we have done brainstorming on it, and the possible solution we can have that if you put a robot instead of manual handling of the upper nozzle changing, the problem can be solved. But with when we there is a high capital engagement is there, then high maintenance skill is not feasible to the current Indian steel manufacturing, and it is not developed also. So later on, we have thought for a come with a solution ingeniously and to develop a solution for this. But the challenges are there here that the area and height constraint is there in the recent maintenance stand. And the next is that the dusty atmosphere. Then the limitation of the energy source in the maintenance stand. And finally the heat that is a high temperature area. So these are all the challenges that we are facing for developing a cost-effective solution. So finally, we have overcome all the challenges and designed and developed a refractory handling manipulator which is cost-effective and very simple and reliable one. So with this, we have designed and developed a simple way semi-mechanical handling manipulator. So the main parts are the vertical arm, that is the vertical pillar, then the primary arm and secondary arm, the pneumatic balancing system, then the clutch and gripper. Let us understand the function of the parts individually. First, the pillar is there to support this manipulator assembly. Then the primary arm and secondary arm are there to give them a movement. So this is the most important while working on the upper nozzle. So there are two arms we have designed such a way that they are giving the freedom of movement. Then the pneumatic suspension system. This is the heart of this manipulator. With this pneumatic suspension system, the operator has to give only 1 to 2 kg of load in case of carry the load of 40 kg. This will carry and as well as balance the total load. So here the operator has to just only guide in the air. He will feel like just to guide in the air instead of taking any load. And there is the sufficient freedom of movement so that he can adjust it and position it as he wants. Then the final is the clutch assembly. It controls the rotational movement of the handle, and it helps in accurate positioning of the upper nozzle, because when we are applying the upper nozzle in well block, accurate positioning is most important. So this will help us the clutch through the clutch assembly. Then the gripper, which will give the positive locking to the upper nozzle during the handling. This is the close-up look of all the parts, spares used in the manipulator. Let us have a video how it works. By this handle, and here is a gripper is there for positive locking. Once it grips, the upper nozzle will not fall down. This is the work of the clutch assembly. It can rotate and you can stop at any angle, 360 degree. Here bearing is there to rotate, then apply the motor easily. This is the clutch. It will give the rotational motion. It will help us the positioning the upper nozzle accurately in the well block. And during carrying, no load will be filled by the operator. And after completion of the fixing, we can easily remove it. Thank you. Next, here we have some of the positive locking system is there and safety features are, we have provided. In case of any pressure drop or any energy failure, the manipulator will stop at its own place only. It will not move anymore. So another after getting the power source only it will move. Next, the upper nozzle locking with the gripper that we have seen, the positive locking we have given. And finally, during the ideal time, we can lock it in the manipulator stand. So the conclusion is that here already we have trialed it and installed it in one of our prestigious customer premises with the help of them. And already more than 500 nozzles we have installed through this manipulator. It is working quite satisfactory. And with our performance, the customer wants to convert all the filter stand with our PRLK manipulator. And it is a very cost-effective solution, and it will reduce the man-machine interference also. And TRLK is working on to add more application like that upper nozzle we have seen, more application like porous plug changing, slide plate changing in this particular manipulator. And it can be customized plant to plant based upon the requirement and based upon the application. And finally, it is in line with the Make in India project of India government. Nothing worthwhile is achieved without any deep thought or hard work. Thank you.
Thank you, Mr. Sujit. Yeah, very nice presentation and development from your side. Questions due to time constraint, we will be taking consolidated questions at the end of the session. Okay, so let's move on to the next presentation from SRU Bhilai. The topic is a study on recycling of used MAC bricks in production of macaron bricks. The presentation will be delivered by Ms. Pallavi Singh. Yeah, you can start now. Any technical issue? Okay.
Hello and a warm evening to everyone. I am Pallavi Singh, Senior Manager, Sale Refractory Unit, Bhilai. Since morning, we are hearing about magnesia carbon bricks or refractories for the sustainable use of refractories. So here I am going to work on recycling of used magnesia carbon bricks in production of magnesia carbon bricks. One of the oldest technical texts in the history of mining and metallurgy, De Re Metallica, lists ore, fuel, and refractory materials as the three substances essential for metal refining. All through the Iron Age, from ancient time up to now, refractory has been closely engages. Refractory has been closely engages in iron and steel making, contributing to human civilization. Refractory Refractory in itself is a huge subject of research. For study purpose, we have limited ourselves to the refractory bricks used in secondary steel making processes, specifically to magnesia carbon bricks. Before we proceed, let us understand what are the characteristics of refractories. First of all, they should be infusible at operating temperature. They should be chemically inert towards corrosive gases, liquids, etc. They should not suffer changes in size at operating temperature, and the obvious one should have high refractoriness. Fifth, is liquids, etc. They should not suffer changes in size at operating temperature, and the obvious one should have high refractoriness. Fifth one, they should have high load bearing capacity at operating temperature. These already has been taken care in the previous slide, so I'll just escape this. Okay. If in this paper we are focused our studies around magnesia carbon bricks. Magnesia carbon bricks are used extensively in steel making processes, especially in basic oxygen furnaces, electric arc furnaces, lining of steel ladles, etc. The evolution and use of magnesia refractories in combination with carbon started in early 1950s with might quartz fraction bonded with pitch. In 1970s, the burn and the impregnated magnesia brick with finite pore size became the standard for the charge pad and the other high wear areas, starting the beginning of the zone lining for basic oxygen furnaces. In 1980s, saw the development of resin bonded magnesia graphite, first with high carbon furnaces. In 1980s, saw the development of resin bonded magnesia graphite, first with high carbon content and then with the addition of antioxidants to preserve the carbon content. Now we'll see the ingredients that are required for the production of magnesia carbon bricks. They are magnesium. Now we'll see the ingredients that are required for the production of magnesia carbon bricks. They are magnesia carbon resin and additives. Now let us understand one by one. Classification of magnesia based on the origin. Magnesia are classified into fused magnesia, seawater magnesia, and dead burnt magnesia. Now these are just a tabulated form of the chemical analysis. Magnesia are classified into fused magnesia, seawater magnesia, and dead burnt magnesia. Now these are just a tabulated form of the chemical analysis of the various magnesia that are present. Fused magnesia is produced by fusion of raw magnesite or calcined magnesia by means of electric arcing and cooled down to crystallization. It has advantages of high purity and large crystal, but they are having poor thermal shock resistance. Seawater magnesia, as the name suggests, this is produced by the extraction of magnesium chloride salt from seawater, followed by beneficiation, calcination, and high temperature. This is produced by the extraction of magnesium chloride salt from seawater, followed by beneficiation, calcination, and high temperature firing. This material is very pure with cryptocrystalline structure and has high lime to silica ratio. Third one is dead burnt magnesia. The natural deposit of raw magnesite is first beneficiated, then calcined, followed by high temperature firing to produce dead burnt magnesia. This material contains negligible amount of boron with high lime silica ratio. Carbon in the form of graphite is used mainly because of its excellent physical properties, such as non-wettability by the slag, high thermal conductivity, low thermal expansibility, fused with refractory resin are used high quantity of fixed carbon, which gives strong bonding property. It possesses high dry strength because of its thermosetting nature. It produces less hazardous gases than tar and pitch. It produces less hazardous gases than tar and pitch. At curing temperature around 200 degrees Celsius, it polymerizes, which gives isotropic interlocking structure, and cold crushing strength, that is CCS, increases with the increase of resin content. There are some other additives that are also added during the manufacture of magnesia carbon bricks. Carbon components contained in magnesia carbon bricks are oxidized by the oxygen in the atmosphere or by the iron oxide in the slag. Antioxidants in magnesia carbon bricks are oxidized by the oxygen in the atmosphere or by the iron oxide in the slag. Antioxidants such as metallic powders are added mainly to suppress this oxidation. Unfortunately, not blessed with high purity magnesia. They are found mainly in regions like Salem and Almora, but generally contains high iron. Hence, these magnesia are not recommended for used in high vulnerable areas. Hence, the high purity magnesia will silica or high iron. Hence, these magnesia are not recommended for used in high vulnerable areas. Hence, the high purity magnesia which is required for the production of magnesia carbon bricks are imported from other countries like Australia, Japan, Turkey, and Netherlands. Now, what are the problems that we are facing when we are procuring high purity magnesia from outside? Because invasion of Ukraine in February 2022 has resulted in chaos in the global natural gas, coal, oil, and electricity markets. Prices of natural gases, electricity have reached stratospheric levels, adding extra cost on production of magnesia. Outbreak of COVID pandemic in 2020 has actually led major economic into prolonged lockdown, and magnesia production has impacted. Volatility in freight, uncertainty in availability has increased, and it has affected our cost of production. So the need of the used bricks that are available with us, as the depletion of the natural deposits of magnesia are occurring very fast. Why do we want to reuse the refractories? Because of the increased prices of raw material, generation of large quantities of used refractories by steel industries annually, dependency on raw material supplies has used, reduction in carbon dioxide emission and energy consumption, and they can be best get the benefits can be best obtained when they are used as secondary raw materials. Now, before going for this study, the thought process that we were having is the resistance of graphite increases up to 3000 degrees Celsius. Hence, the carbon present in the leftover thickness should be unused. Melting point of magnesia is also high. Hence, the leftover thickness of the bricks remains untapped. However, the impurities such as oxide, lime, silica increases due to the interaction with slag and metal. Alumina from aluminum powder combines with MgO at higher temperature to form magnesium aluminate spinel, and this is having a very high refractory properties. So the presence of this spinel in grog may help us in getting better refractory properties. So we have gone for the sample preparation. Two type of grogs we are taken for this study. One were normal grog and the other one was the calcine grog. The metal and slag sticking on the bricks were removed from the grogs. The grogs were then crushed to the desired size fractions. Analysis of the grog was done at the laboratory mainly for the constraints of carbon and MgO, and here are the results. And we have for the combination of the grogs, and we have prepared 8 samples, and we have undergone the physical testing, and here it is tabulated. So from this we have got our right now we are using the grog in our production unit. So what we have concluded from this study is, and what has motivated for us for taking up this study was, other than the tangible benefits, there were many untangible benefits. The use we have come to of virgin raw material for manufacturing of magnesia carbon bricks, if used safely, save 10% of its virgin raw material cost. If it is virgin raw material, it will save 10% of its
So thank you very much. So let's move on to the next presentation. Next presentation is from RHI Magnesita. The topic is Insight into BOF Bottom Purging. It will be presented by Mr. Kaushik Das Gupta. Yeah, we don't have much of details of Mr. Kaushik Das Gupta, so let's move on to the presentation. You can start, Mr. Kaushik. Thank you.
Yes, sir.
So, hello. So basically, this is all about an insight into the converter bottom purging. Doesn't change. So basically, this is a converter inert gas purging CIP layout sort of thing. You have a gas station and electric control that is connected to the and the bottom purging supervision screen that goes the rotary joint in the trunnion area down to the bottom to us. So basically, it consists of purging flux piping, rotary joint, gas control box, visualization, archival storage, bottom purging patterns linked to steel grade portfolio. So basically, when we talk about bottom purging element, it is just not another piece of magnesia carbon that you sort of build sleeves into and expect it to deliver the gas. Because if I inadequately develop the element, results in severe thermal mechanical stress, excessive wear and blockage, and we will not be able to reap the metallurgical benefits for a better half of the campaign. So temperature distribution in bottom during blowing. So what happens without bottom blowing? The measurements of bottom show regular fluctuations. Temperature starts growing at the beginning of filling as usual, and after tapping, the lining cools down. But on the contrary, when we have a bottom purging in place, we have this bottom blowing element developing a cold spot, and the cooling effect is proportional to the flow rate. Look at the temperature there. The hot phase temperature is always around in certain severe thermal stress in the bottom element area. It is much higher than the rest of the bottom. So is often high enough to exceed the material strength. So it makes the blowing element and the brick surrounding it most vulnerable to compressive spalling. And these are the degrees of compressive spalling, the plastic strengths from nil to low to moderate. So when magnesia carbon manufacturer, plant manufacturer are often tempted to use a refractory that is as strong as possible. That will make the as strong as possible so that the cyclic loading and unloading I was referring to, that will be taken care of. So in these situations, what and tough crack grows so long that the intact cross section cannot support the load and the brick fractures. See, designers must be concerned with both the strength and the toughness of the material being produced. The strength must be large enough so that the material can withstand the applied loads produced. The strength must be large enough so that the material can withstand the applied loads without deforming. And yet the toughness must be sufficient for the material to withstand the pressure of fatigue cracks without failing catastrophically. So basically, it is an optimization of the two, strength and toughness. And for a given load, as fracture toughness increases, the reflex without failing catastrophically. So basically, it is an optimization of the two, strength and toughness. And for a given load, as fracture toughness increases, the refractory can tolerate fracturing. Now, resistance to initiation of crack is important, but more important is how ably you can control the crack propagation once it is generated. This is where the right flex comes into play. A good purging element, a bad purging element. So quality of magnesia aggregate and graphite flex used will matter at most. Grain size distribution, grain size distribution, aggregate matrix interface, porosity, right additives and binder. So in R&D terms, we call it effective tortuousness of the crack path. The crack is there, so I'll have to inhibit the crack in such a way that it fills the most resistance in propagating. So what the matrix does, it transforms the crack activation energy and energy dissipation from a burst type to a very so what the matrix does, it transforms the crack activation energy and energy dissipation from a burst type to a very slow releasing type. So basically, we talk about these two type of resistance. One is R and one is R triple dash. Resistance, one is R and one is R triple dash. This is basically a crack nucleation resistance. The crack is initiated. It represents the maximum temperature gradient before it's formed. So basically, this is expressed in degree centigrade or degree Kelvin. So that is higher the value of R, the greater the resistance to nucleate cracks due to stress. Value of R, the greater the resistance to nucleate cracks due to stress by thermal origin. And coming back to R triple dash, this is basically a resistance to crack propagation, because every crack needs certain amount of minimum elastic energy in order to propagate in the fracture zone. That means higher the value of R triple dash, the greater will be the resistance to propagation of cracks. But as a refractory manufacturer, what matters to the refractory manufacturer is the R triple dash, because it is more relevant in refractories, since these refractory materials by inherent nature are large population of inherent flaws, which are pores and micro cracks. So for us, R triple dash is more important than R. I will give you an example and show it. See, I have three samples A, B, and C. Samples A, B, and C. A has the least fracture strength, 23.4. Fracture strength, 23.4. B is 37.4. C is 24.1. But the deformation and fracture for A is highest, 0.5. So it fracture for A is highest, 0.5. So it has got a very good value of R triple dash, 2.9. Good value of R triple dash, 2.9. So the brick A meets the best combination of parameters of R and R triple dash. Despite having the lower value of fracture strength, 23.4 megapascal, A has a higher value of deformation percentage at fracture, 0.5, owing to a much better placed R triple dash, thus increasing the strain at fracture. For B and C, the higher values of fracture strength is offset by a speedier propagation of a fatigue crack to the point of fracture. See, the original fatigue crack, even though it is 37.4, the speed of crack growth to 37.4 is much faster than 23.4. So now coming to a certain bit of fluid dynamics, which is associated with this porous purging plug operation. This is very important in understanding the interdependent nature of pressure, flow, and velocity when we design a system. But most important is to learn which variable is critical at what stage of that going process. So basically, I will not go into very details. Velocity, it gives you the thrust. If you want to remove a blockage from a pipe, you need a thrust. So there, the volume flow rate doesn't tell you a high volumetric flow rate. This is a very common misconception. If you increase the velocity of a fluid, that doesn't mean it has a high volumetric flow rate. Volumetric flow rate. This is a very common misconception. If you increase the velocity of a fluid, that doesn't mean it has a high volumetric flow rate. Flow is critical when the fluid needs to fill a space. You need to supply a given volumetric flow rate that continuously fills and replenishes the application space. And pressure, if an application is expected to have a high back pressure, the system must be rated to operate at that pressure. Characteristics of a system with high level of back pressure, as we all know, multiple lengths or long lengths of hose or pipe, and applications where the gas is forced through small openings, just the case of bottom purging elements. So basically, these are the concepts that go into making an efficient bottom purging: back pressure, closed loop fluid control, volumetric flow rate and mass flow rate, pressure control and flow control valve. All these put together will give the working principle of efficient bottom purging in place. So basically, I will skip down some slides. Yeah, I've got 2 minutes. So this is basically the concept of back pressure. As you know, the fluidic substance moves through a pipe and it has a lot of air energy and suddenly it gets a blockade. Then the energy hits the wall and suddenly it gets a blockade. Then the energy hits the wall and it bounces back like ripples. So basically, when I have a minimal back pressure, the flow is very fast, as you can see. But the slowing of movement in the pipe happens. This is the actual meaning of the loss is translated back up the pipe. Upstream, the loss is translated, reducing the momentum of the entire stream. The flow is considerably reduced now. But this is very important. The flow remains essentially in the same, but the flow is reduced due to resistance. Into this, this is important. Volumetric flow rate. Volumetric flow rate is basically the actual flow rate you engage. It is always dependent on pressure and temperature, and hence recommended for measuring volumetric flow when high accuracy is not needed. Whereas mass flow rate is basically independent of pressure and temperature, and hence more reliable and higher accuracy and repeatability.
Just a prompt. Already 12 minutes have crossed. Just finish up, please.
So, of this difference in volumetric flow rate and mass flow rate. See, I have this standard temperature and pressure 1 atmosphere and temperature 270.15 Kelvin. The volumetric flow rate is 200 cubic centimeter per minute. But if I change the standard temperature and pressure to non-standard conditions, I have changed T, and there I have changed P and T both. See, the volumetric flow rate has changed to 219 and 146. Okay, but the mass flow rate remains same, 200 standard cubic centimeter per minute. Unless and until you change 0.25, 0.25, 0.25, this 200 will remain same for all the volumetric flow rates of 200, 219, 146. So basically how a mass flow rate works. See, this is the original scenario. The volumetric flow rate is coming to 219 centimeter cubic per minute. And because of change in pressure to 1.5, I have a volumetric flow rate of 146. So the scenario has changed for me, which is bad for the plug. So what the MFC will do, it will again work out that 0.250 grams per minute to 0.376 grams per minute, thereby giving the restored 219 centimeter cube again, the initial stage. Okay. Can I show this animation? Just 1 minute. It is good one.
Okay, if time permits. Thank you. Many other presenters are waiting.
Okay.
So let's just not take the time. Thank you, Mr. Kaushik. Although a lot of data and design aspects has been discussed about the bottom purging. It is although a challenging issue for all the view of operators. But a lot of work is required to be done in this area for getting a reliable plug which can operate throughout the life of the converter. Right. So thank you very much. Our next presentation is from Dalmia Bharat Refractory Limited. The topic is use of recycled material in the RH Degreaser lower vessel magnesia chrome bricks. It will be presented by Mr. Abhishek Mitra. Mr. Abhishek Mitra is a BSc Chemical Honors and BTech Ceramics. He is having 10 years of experience in this area, and he has many publications and patents in his name. So I just request Mr. Abhishek to start his presentation. Thank you. Kindly restrict to the time and skip away anything which is already discussed or for the forum. Thank you.
Okay. Yeah. Good evening, everybody. So my topic will be a case study on the use of recycled material in RH Degreaser lower vessel, which is generally we use magnesia chrome brick there. So this is how we will proceed. We will see the introduction, then the analysis of the recycled material, trials, finally conclusion. Here, this is a RH Degreaser, which we all know it is one of the best and most preferred secondary refining process which is being used for productivity and the efficiency. But for all the refractories which is being used in the RH degassers and in the snorkels, they are subjected to very severe conditions like the high speed circulation of liquid steel, the chemical reaction in the RH vessels, the temperature fluctuation, as well as the oxygen blowing and the vacuum condition inside the vessel. So in RH degasser, due to all the condition which we have already stated above, so the rather the best bricks which is now being used is magnesia chrome bricks. So this is used mainly because of its very excellent resistance to corrosion and erosion, high temperature stability, low thermal expansion, very high hot strength. So that is the leftover thickness that is being either thrown away or being used as landfills. So this now at this moment when the increasing all over the world, there is dependence of raw material, mainly the fused magnesia chrome and magnesite which comes from China and other foreign countries. Also need to reduce the carbon emission and the energy consumption. So here what we have done, we have taken a recycled material. This is the chemical analysis which is showing around 65% of magnesia and around 18% of chrome. This is the chemical analysis of the part of the refractory where there is no slag or metal. So if you take a total refractory brick, the area where there is penetration that has been cut away and the rest has been used. So in the XRD, we have found all the phases which is like the Pericles phase, chromite and magnetioferrite. No low melting phases have morphology of the recyclate, which we name MCR. 5 batches where we have used this recyclate material. We have made bricks and fired it at very high temperature of around 3 centigrade in a tunnel kiln. So here are the properties, in the physical properties which we are seeing here. The thing is that in T3 it is giving the property which is almost nearer to the RS. RS is the standard one, which is after 30% of use of the recycled material. When we go to 40%, there is a very high increase in the apparent porosity and decrease in the HMOR. So these are the two main properties which is being used, or rather which is required in the RH degasser for better performance. This is the PSD, that is the pore size analysis. Here also we can see up to 30% use of this recycled material. We come to 40% and 50%, it increases drastically to XRDs. So I don't need to explain, just we have see that. We can see the number of pores are very scattered as well as channel pores are present. Whereas in T3, the pores are less. But due to recycled material use and quality of the recyclate, this type of pores are available, which we have already seen in that table, that there is almost 0.88 increase in the apparent porosity. So this is the rotary drum test with a synthetic slag. So here in that index, where there is a corrosion index, we have seen that the corrosion index is also decreasing from the virgin material to as we increase the recyclate. But after T3, that is after when we cross the 30% limit, it decreases to 84%. That is almost 16% decrease, whereas up to 30% it stays in the 1992 range. This is I am talking about the pore size distribution, and that is because this is an equation which depends on which the penetration of slag inside the refractory. There is L is the penetrating distance and R is the average pore size. So as the R will be increased, the penetration will also be increased. So we need to keep this pore size minimum to stop this penetration. Regular 100% virgin material was giving a life of around 80 to 85 heats with a LOT, that is leftover thickness, of 120 after use. We have used the same and the total life is around 83 average with a high of 87. The average LOT is around 100, which is okay because for the lower vessel life almost decreases, almost depends on the life of the snorkel. So in that plan, the snorkel life is been taken around 80, 82 hits. So these are the some date planned. So we have an average life of 83 with an average LOT of around 100. So I need to conclude by saying that the here whatever we are using in the recycled material up to 30%, it is performing as good as 100% virgin material. Though one is to be said that this recycled material quantity or rather quality should be better. It's not the total that grog mix that that used, and we have got the similar life. So very important thing for us so that we can stop the import of material from different foreign countries, and we can use our own recycled material to make refractory. Yeah, thank you all from my side.
Thank you, Mr. Abhishek. Thank you for sticking to the time. Really, this is a very challenging topic, recycling of refractory waste materials and making it useful again. So challenging as well as very useful for the whole industry as well as steel makers also. It will reduce the cost and dependency on the foreign source. Thank you. Our next presentation is from JSW Odisha, and it will be a joint Dolby. I think one of the speaker will be joining us, Mr. Ashish Kumar Sarkar will be joining us online, and another presentation from JSW, it will be offline. So are we ready with the online? First offline? Okay. Who is asking this permission? Yeah, Mr. Ashish Sarkar has joined. Okay. Mr. Sarkar, can I just intervene? Yeah. I am Amar Gupta from BSL Bokaro. This will be a joint session between Odisha and Dolby, JSW. So kindly stick to the time of 5 minutes so that offline presentation can also be taken up during this time. Okay.
that of the furnace by doing achieving improved quality, safety, and improved quality of magnetic carbon based working lining to increase the capacity from 95 to 1055. That position was necessary last year, December, and within 6 months we completed all the 105 ton pathways according to dragging capacity also today, and also our DSP, that DSP we have changed the segment, we have changed the vertical lane. Now that DSP was earlier 2.8, now it has been running with capacity of 5.5 tons per hour per minute. All these things are our in-house technology. And actually, I have seen this discussion to organize that if I am offline, I am not able to do all these details. This is the main thing of our driver. And we completed in 8 months. Now everything is right. We are able to see the capacity of our one and go to 3% in quality and quality.
Thank you, Mr. Sarkar. Thank you very much for joining online. And it's a nice initiative on part of improving productivity at JSW Odisha. Thank you very much. And now we can start with the offline presentation from the JSW Dolby. Kindly stick to your 5 minutes time, please.
Myself, Nimanand Sahu, I am from JSW. With me, BN Dubey Sahib is there. We have come from JSW Dalvi. We are presenting a paper about future refractories in the steel ladle linked to CSP mill of 3.5 million ton. It is reducing dust emissions. It improves coke quality by reducing moisture. Also, heat energy being saved by converting into electricity. It's also environment friendly. Actually, with normal fire clays, we face a lot of difficulty in CDQ. A lot of damage happen in the pillar zones and in the arc zone also. What we have decided, we are going for mullite silicon carbide bricks for the pillars and arc. It has very good high aerial and key properties, very excellent mechanical strength at high temperatures, hot abrasion resistance, and we are expecting a life of 2 years instead of 1 year with the regular fire clay bricks. CDQ is very costly thing for us, so if you will take a shutdown 1 year each and 30 days, it's very costly affair. So it will be very useful for us. Why silicon carbide is so good? Because very high temperature reducing atmosphere and forms a glassy layer, and that helps in achieving the desired properties. We have another experiment done in the steel ladle short treating. Actually, in the metal zone that the damage happened, we have not changed the entire wig on the top surface. 30 to 40 ml of short treating is being done, and that is the good life is being achieved. This is the after application photos. This is the typical material is being used at the tabular alumina based raw material, and the alumina is 90%. And this is the benefit of short treating. With 2 repairs, we have achieved life of 170 campaigns. Due to monolithic use, we have drastically reduced the cost, and also it's locally easily available, so inventory cost can be reduced, and non-magnesia based problem can also be resolved. Thank you.
Thank you, Mr. Sahu. Thank you for sticking to the time.
Thank
you. Really nice initiative part of improving the ladle refractory and the coke dry quenching refractory at JSW Dolby. Our next presentation is from SRU RDCIS team. The topic is improvement in lining life of 300 ton converter in BSL sale. Primarily, it's from my area, and it will be presented by Mr. Rahul Pandey from SRU Ranchi Road. Mr. Rahul is manager production, and he is a BTech in ceramic engineering from IIT BHU 2014 pass out. He has 5 years of experience in alumina silicate refractory manufacturing, and last 1.5 years 1.5 years he is associated with MCB production. He has presented 2 international papers at this stage. I request Mr. Pandey to start his presentation and stick to the time, please. Thank you.
Hello, good evening all. This is about the improvement in lining life of 300-ton converter at BSL SMS2 during the year 2007 to 2022. Last year we did not have any converter, so 2021 is written. So our basic aim is to reduce the specific consumption of refractory, improving life and reducing heat cost, we can say, but the main aim is reducing specific consumption of refractories. So the basic from 2007 to 2021, we have done many changes to our refractory lining, the materials and the process that we manufacture, and that has given significant improvement in the life. So first, about raw material selection, magnesia has been already talked about before. There we need large periclase grains, thereby decreasing the impurities at the grain boundaries and minimizing the grain boundaries itself in the refractory. But also, fused magnesia cannot be used 100% because of its other disadvantages. And fused magnesia has the highest grain sizes. 3 types of magnesias are available right now with us: seawater magnesia, fused magnesia, and dead one magnesia. Specification ranges about from 96% to 98% magnesia content, 0.4% iron to 0.8% iron in different raw materials. Calcium to silica ratio is from 2 to 5. Then we have other raw materials. Graphite, we have 94% and 96% that are currently being used. 98% is also available, but that is very costly, so not cost economics, and so we are not using 98%. Antioxidants, we have aluminum, silicon, and boron carbide. Silicon is not being used. Boron carbide is very costly, so leaves us with aluminum being used as the antioxidant. Binder, we use resin bonded as MacCarbon in MacCarbon bricks. So there are 2 types of resins, Resol and Novolac. SRU Ranchi Road is currently using Resol, SRU Bhilai is using Resol, and SRCL is using Novolac. Then other additives are like pitch powder and etc. are used to increase strength and reduce open porosities. So things that we did at our end is we made many different compositions, changed different size distributions, and had an optimum size distribution made, which gives the best properties. We had experimented many mixing sequences, and we had an optimum sequence adding which, after which, and how much time you mix at. So we had a good mixing sequence. Volatile matter was an issue. Higher volatile matter will lead the cracking in bricks. Lower volatile matter will leave the brick with high pores. So bulk density will be reduced. So we have a good volatile matter control. We have to do it. So 1 to 1.4% is the current norm. Specific pressure during pressing is also important. 2 is the norm. The higher, the better. Increasing specific pressure decreases the porosity, increases the strength, CCS, and the cogged porosity of the brick. Also, during heating, you have to take proper care so that bricks do not burn. During operation, thanks to BSL SMS2, different things were tried. Silica was an issue. Higher silica leads to increase in reactivity with magnesia. So less silica is required in slag. CO addition was done to increase the basicity. Iron oxide in slag was 12 to 16%, but we get 18 to 22% also at different times. So that is that. Magnesia is also important in slag because if it's not there, then the slag will take magnesia from my brick and brick lining will be reduced. Temperature of less than 1670 degrees preferred, but anything we can say that 1600 is also okay. That is not okay because that will improve the life of converter but decrease the life of ladles. So 1650 to 1670 is our range. Measure taken other than operational aspects are, we changed the design. Many years ago, there were two bricks combinations being used. We rationalized it. That reduced the lining pattern. The loss of wear was zonal lining pattern was also done in different compositions were tried in Jarjpad, Tap Belly, and other zones. Reblows are the thing of past. So slag addition was LD slag addition was done. Dolomite lime was done. Slag splashing was done, and drainage of slag through tap hole was done, just to try that we can increase the life of the refractories around the tap hole sleeve. We have drainage of slag, some slag from tap hole. These are the results. We in 2007 and 2008 we had a life of 2,238 and 94. In 2021 we achieved a life of 3685 and 3721. So in last 14 years we have gained 2200 to approximately 3800, and we are also supplying again this year, and we'll have a better composition this time. Thank you.
Thank you, Rahul. We have full confidence in the total SRU team, and I hope we will be doing better and better jointly with SRU. Thank you. We have saved 2 minutes on your presentation. Thank you. Next presentation is from Mathan Ceramics Limited. It will be based on the importance of spinel bricks in special steel making processes. It will be delivered by Mr. Deepak Mane from Mathan Ceramics. Mr. Deepak Mane is a metallurgical engineer from College of Engineering, Pune. He did his graduation in the year 1990. His area of interest is technical services and data analysis. Having experience of more than 12 years in secondary steel making, mini mills, and 20 years in refractory industry, mainly focusing on refractory engineering applications, technical services. He has been associated with many projects and traveled extensively to many countries across the globe. So I invite Mr. Deepak Mane from Mathan Ceramics to start his presentation. Thank you.
Thank you, Chairman, Co-Chairman, respected guests, speakers, and all the delegates. So I'll not take much of time because we have gathered a lot of knowledge since morning. So I'll just go through it. The topic we choose is the importance of spinel bricks in steel making. As we found recently, the many technological advancements are happening. So in the refractory industry also, we are expecting the same improvements. So I'll just go fast through this. India being the second largest steel producer with a production of 110 million tons in year 2021, and we are the production capacity of India presently is 150 million tons. With the projection by Ministry of Steel, so we are expecting by 2030, the India's steel production will reach to the level of 255 million tons, and the production capacity will be over 300 million tons. So the Make in India drive, which is the ensures the domestic steel production and consumption further. So further to this, India's Atmanirbhar Bharat initiative is an inspiration and driving force to the Indian refractory industry. So Indian refractory industry has revived, industry's growth has been revived since 2017 crisis in raw material availability from China. So Jharkhand government cell units are very much conducive for the refractory industry in the state. So as per the Fortune Business Insights, the data says the global refractory market size will reach up to $45 billion by 2029. And we are expecting out of it, so the Asia refractory market will grow much faster compared to the rest of the globe. You can see the right side, the photograph where India is supposed to be in the highest growth rate in refractory industry. So growth rate in India will be very high. Further, refractory plays an important role, and it is an integral part of the steel industry. It is a part of many industry, but steel industry, iron and steel industry is the largest consumer of refractory. In steel making, we have seen since morning, we have seen a lot of tech. We were talking about the to weight ratio of the steel, so steel qualities. So hence, with this technology advancements, so we need the steel demand for ultra low carbon steels and higher productivity is there. So simultaneously, as the steel industry is going through the many technological changes, refractory industry has also gone. New product emerged as a carbon refractories for steel ladles to meet the requirements of ultra low carbon steel grades. Talking about the spinel bricks, so main are the properties we are looking into: erosion resistance, corrosion resistance, thermal resistance, that is a kind of elasticity, and the slag penetration resistance. So based on this, mainly the steel ladle refractories were designed with mainly the carbon containing refractories, the magnesia carbon basically. Magnesia carbon containing refractories basically the linings. Technological developments, the steel, so as we are aiming for low carbon steel grades to achieve the thinner, to manufacture thin steel for so basically the spinel refractories are developed aiming the no carbon pickup from the refractories to the steel. Spinel bricks mainly targeting, because if we see the right hand side, so the design parameters, the erosion resistance and all those things, so compared to the carbon containing refractories, spinel refractories is more prone to the erosion, chemical erosion kind of in terms of the slag area. So less, yeah. So that is, and basically the refractories are replacing magnesia carbon refractories because for steel ladles, and we have the aiming the ultra low carbon steel grades, because IF, so the requirement of carbon is 20 to 30 ppm, where even a couple of ppm numbers it matters. So hence this is the requirement of no carbon or carbon free refractories like spinel. So then the RH degassing, mainly these are designed bottom. So Then the next parameter what we are looking into is the volume stability during service. So better spalling resistance and less slag penetration. So all those, whatever is the right side, you will see the what Maithan has developed the spinel refractory bricks with the typical values or typical properties as shown in the graph. So I'll not elaborate it because that is not my area of research in ceramics, but application more. I will focus on the application side. We see in the spinel bricks or conventional magnesia carbon bricks. It is where no carbon pickup in the steel refractory lines. Then to enhance the metal zone body to complement with the slag zone life and enhance the overall ladle performance and reduce the ladle turnaround time. Then will reach to the reduced specific consumption of ladle batteries, resulting in the cost reduction and heating and manpower, etc. So most important factor in spinel bricks is the nowadays we are talking about energy conservation. So energy saving is the major issue. As spinel refractories are less thermal conductive, so 3 watt, 3 is to 10 watt per meter per Kelvin. So that gives the less heat loss in spinel refractories. Then it's a more reliable refractory in terms of the safety, because during high temperature firing, so any defects, any imperfections in the refractories, that will be surfaced out immediately. Then boost of to the refractories based in indigenous raw materials. That is the one of the important aspect, because dependence on the imported magnesia from China will be reduced by using spinel refractories. Then reduction in spinel refractories. So, and but most important is the is recyclable by simple and hassle-free processes. So application and results going, we have supplied our spinel refractories in 130 ton, 180 ton and 350 ton ladles. And
Sorry to interrupt you, Mr. Mani.
Just
Can we conclude?
Just 2 minutes.
Yeah, okay.
We have supplied those refractories. These are the results. So final we are going. So 140 ton, 130 ton, 180 ton and 350 ton ladle. Supplied to Bokaro Steel also. So it will be tried in the month of October. So if we see the results, so metal zone and bottom, the performance of the magnesia spinel bricks, we'll see the difference, the increase in the performance, and hence the reduction in the specific consumption. And we have few carbon pickup from the refractories, that is within the range of 2 to 5 ppm by using the spinel bricks, metal zone and bottom. Heat loss calculations are yet to be done, so we are not yet completed. But for just, we have monitored the shell temperatures throughout the campaign, and this is it is clear cut. We can see the 20 to 30 degree shell temperature difference in spinel area and slag. Energy saving aspect of spinels. So this is finally the conclusion is in Make in India drive. So to enrich the product portfolio of Indian refractory industry, so spinel is the new generation refractory which is coming into. Indigenously developed alumina spinel bricks achieved the highest performances compared to the magnesia carbon. Good future and more demand for the spinel refractories because of the changes in the steel requirements, steel quality requirements. That is no carbon pickup again, the less specific consumption, cost-effective solutions and energy. So in-house developments with combination of raw material sources yielded the results, hence reduced India's dependence on the China magnesia materials. Thank you.
Thank you, Mr. Mane. Thank you very much. So all the presentations are over, all the 8 presentations. Can we give a big round of applause to all the 8 speakers? And cooperation from them was obvious because we could, although we were late, but we could conclude in time. So thank you very much for that also. So this house is open now. One question for one speaker because time constant. So I request just raise your hand and introduce yourself and ask name the speaker. Whom do you want to ask the question?
I am Shudeep Chandra from IFGL Refractories. My question is to Deepak sir. He has a very nice presentation. Sir, thank you for enlightening us the benefits of the spindle brick. It obviously seems that it will be a magic solution to many things. Is there any negative about that brick? And if it is only positive, why the steel industry is not taking it more seriously and completely replacing the magnesia carbon bricks in the ladles?
The negative as it is, there is no negative in this refractories. There are each and every product has got its own importance in terms of the application. Some products will be useful, some are not, because the spinel refractory is mainly the alumina based spinel, so magnesia carbon refractory. So definitely it cannot replace 100% the magnesia carbon.
No, but if I take the ladle bill of materials, metal zone and bottom will be a very significant quantity. So if really it's a magic answer, I mean the steel industry should definitely look into it, and also the refractory supplier should also promote it in a very big way. But what we see that in India, the use of spindle bricks have not picked up in that way. Only we are limited to certain IF and US because of the demand from the, the process of the less carbon pickup requirement. What I mean is that is there any cost negativity compared to the magnesia carbon? If it is too costly than the magnesia carbon, I don't know. It's just a question.
No, that is a dynamic situation because that we don't know how the market is driving. So that we cannot comment. But definitely there is a negative thing in the sense because these refractories, because of the higher porosity, so these are not recommended in terms of the degassing areas like vacuum degassing, and in case of silicon kilns in comparison to the aluminum kilns.
Thank you.
So there is a difference.
Thank you, sir.
Thank you. Can we take any other questions? Next question, please. So no more questions. Thank you very much. We had 8 very good presentations from TRL, say SRU, RHI, Dalmia, JSW, again SRU and Manthan Ceramics, and all were full of informations and the concepts behind all the designing parts and the inputs from academia and research institutes. Many things are done, and I hope it is required to be continued in wake of what we discussed in the earlier session, cost of refractories as well as our dependence on foreign sources for technology as well as raw material. And the way we are going ahead with our plan for maximization of our resource utilization as well as improving the production in overall production in India to 300 million tons. So refractory will be a very vital aspect over here. Even considering the circular economy and environmental production, Recycling will be a next challenge where many organizations are working for recycling, for reducing the cost as well as for the protecting our environment also. So thank you very much. Thank you, Mr. Suchit from TRL, Pallavi from SRU, Mr. Kaushik from RHI, Mr. Abhishek, nice presentation on recycling from Dalmia, Mr. Ashish Kumar Sarkar, who joined us online from JSW Odisha, and Mr. Sahu from JSW Odisha, Dolby, sorry. Mr. Pandey from SRU, associated with BSL 300 ton converter. And last but not the least, Mr. Deepak Mane for very insightful research and informations on spinel bricks, which is the future of our refractory as far as we can see in terms of improving productivity, improving the ladle volume, production of IF grade steels, as well as reducing dependency on foreign sources. So thank you very much. Thank you, everybody. Thank you.
Thank you, sir, for conducting the session so well. And I thank the audience. Huge round of applause. Presentations made by presenters. Are you all awake? Can we have it from you? Thank you so much. That's so nice to see the crowd out here still listening to the presentations. And thank you, session chairman and the co-chairman, Mr. M.R. Gupta sir, CGM SMS2 and CCS, and Shri Sushant Sarkar sir, GM in charge SRU. Really well maintained, sir. And the best part I like is about the whole session was the recycling, which is quite an interesting topic for me, because we do a lot of data mining at workplace, but mining with the earth, not justified, sir. We need to save the earth, Mother Earth. So a lot of presentation was there on recycling of the material. Yes, we need to work upon it. And whatever we do, we are doing for the advancement of our steel industry, but we need to take care of the earth too. So thank you very much for the session, sir, and hosting it so well. I'd now request our session chairman, Gupta sir, to kindly hand over the certificates to the presenters, and our session co-chairman to hand over the mementos to our presenters. I'll call first Mr. Sushant, sorry,
Thank you, Sunita.
Suchit Kumar Mata. Mrs. Pallavi Singh from SRU Bhilai. Mr. Kaushik Das Gupta from RHI Magnesita. Mr. Abhishek Mitra from Dalmia Bharat Refractories, Rajgangpur. And I request on behalf of Ashish Kumar Sarkar and on his own behalf for making that wonderful presentation. Mr. Rahul Pandey from SRU. And Mr. Deepak Mane from Math and Ceramics. Thank you, sir, for doing the honors. And I request to kindly come forward on the stage and present the memento to the session chairman and the session co-chairman for hosting the session so well. Thank you, everyone. With this, we come to the end of today's